ಕೊಡಿ ಸಾತ್ವಿಕ್ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ. Yes. Good morning, dear students. Welcome to the most awaited session on mathematics, your paper 3, mathematics, statistics and logical reasoning by CA Vindhya ma'am. Before I hand over the session to ma'am, let me quickly introduce ma'am to you. We have with us CA Vindhya V. Hegde, a chartered accountant by profession. Madam is a partner at Karthik and Vindhya Chartered Accountants, Faculty of Business Mathematics and Logical Reasoning at CA Foundation. Madam has been teaching since 2018. A very warm welcome to you, ma'am. Over to you.
Thank you so much, ma'am. Thank you for the introduction. A very good morning to everyone. A very good morning to my dear students. So I'm going to take up business mathematics to you all. The session will be today, tomorrow, and tomorrow also in the evenings. So let's quickly start. Before we get into the concepts and before we get into the chapters, first let us start with the important topics, as in what is important to you and the marks allotment of each topic and a few tips for your examinations. Okay, so just a minute. Yes. So quickly, let's go through what chapters do we have for us. So first chapter, as you all know, is ratios and proportions, indices and logarithms. Right now, we're just going through what the chapters we have. And quickly after this, I'll also give you the marks allotment of a few attempts of every topic. So you know as to, okay, this chapter is going to fetch me more marks, or this chapter will have more marks for me in the examination. So the second chapter that we have is equations. The third chapter is linear inequalities, followed by fourth chapter, time value of money, basic concepts of permutations and combinations. Then we have sequence and series. Then we have set relations and functions. And lastly, we have calculus. Okay. So now, before we get into the marks allotment, I would like to tell you a little bit of important note or important tips that you need to consider before you get into the exam hall. First of all, you need to know that it is an MCQ based question paper where you have 100 questions, correct? So you have 1 mark per question. And you also know that there is a negative marking, that is 0.25 or 1/4 of a mark, 1/4. That is the negative marking for every wrong answer that you give. Okay. And the total time that we have is 2 hours and not 3 hours. 3 hours is for paper 1 and paper 2. In fact, you also do not have any reading time in this paper, unlike you have for paper 1 and paper 2. So your 15 minutes of reading time is not there in paper 3 as well as paper 4. So you have just 2 hours. And if you consider it in number of minutes, it is just 120 minutes that you have. Okay. Then the next part, very important part, which is that the questions are going to be in a random order. It is not going to be in the order business mathematics 40 questions, logical reasoning 20 questions, followed by business statistics 40 questions. No, it is going to be in a random order, which means first question could be of statistics, could be of mathematics, or could be of logical reasoning. Unlike the mock test papers which have been released by the institute, here you do not have it in the order. So the questions are going to be in a random order. You need to be prepared for it. You have to be prepared for it, because you cannot go with the mindset that, okay, first 40 questions, maths, then logical reasoning, and then statistics. That is not how it is going to be there in the exam. So you need to be prepared for it. Moving on. See, very important next point. Once you solve a question, you get the solution of it, right? You get the answer, A, B, C, D, whatever options you get. Let's say you got answer as option A. Don't keep it for the end. Don't wait till the end moment to mark the answer in the OMR sheet. So what do you need to do is, as soon as you get a solution, quickly go to the OMR sheet, mark the answer, finish it off. Okay? Because as you all know, time is a constraint in our paper. You cannot keep marking of the answers for the last minute. You might end up fumbling or making mistakes when you mark everything at the end. So I would suggest you to mark as soon as you finish. Once you finish a solution, mark the answers. You're done and dusted then. Okay. Next, you have to mark only in HB pencil, that is in the OMR sheet. When you mark the answers should be marked only in HB pencil. Okay. But other things can be written, like when you write the roll number and everything, that can be written in a black pen. Okay. And one more very important thing is the rough work, that is the solutions, that can always be done only in the last page of your question booklet. You won't get a separate answer booklet or anything, unlike paper 1 and paper 2. You will be only given one booklet, okay? And the solutions, the rough work should be done in the last page. So these are a few important things that you need to remember before you get into the exam hall, okay? Moving on, let's understand the marks allotment. Yes. Yes. Okay. So if you can see here, you have from June 23 up to November 2019. I've given you the marks allotment of every chapter here. Okay. And if you can observe very carefully, your chapter 4, that is the time value of money, has been given for highest importance, which means out of 40 marks, we have around 14 marks from that chapter. It has been almost like consistent 14 marks from that particular chapter. So you know that it is a very important topic. This topic I will be covering up in tomorrow's morning session, that is from 10 to 1. Okay, let's start with chapter 1. So if you can observe very carefully, ratios, proportions, indices, and logarithms, I've given it separately. It can come up to 4 to 5 marks, okay? That can be the average that you can consider. Most of the attempts, it has been asked for 5 marks. So 4 to 5 marks is the average that you can consider for ratios and proportions, indices, and logarithms, okay? Ratios and proportions and indices, and logarithm, if you can see, an average of 2 marks that you can consider. And in the previous attempt, if you observe very carefully, ratios and proportions was not asked. That's okay. That's fine. It's not that we are relying on one chapter to score our marks. We have to study everything. Yes, we have to understand everything. Yes, so we cannot like come into a conclusion, okay, we'll skip this chapter or we'll not do this chapter. No, that is not possible. Moving on, we have equations. Yes, if you observe, equations can be asked for an average of 3 to 4 marks. Yes, sometimes it doesn't ask for 6 marks, sometimes 5 marks, but most of the cases it doesn't ask for 3 marks. Next, moving on to linear inequalities. Only in the previous attempt it had been asked for 3 marks, and in December 21 attempt it had been asked for 2 marks, but otherwise it has been asked for only 1 mark. Next is your time value of money, which is always most important chapter from the point of view of your exam, yes, and the concept wise also. It is one of the most important chapter when you have to study. Okay, moving on, you have permutations and combinations, which is asked for an average of 4 marks. And then you have sequence and series, again for an average of 3 to 4 marks. And then sets, relations, and functions, again for an average of 3 to 4 marks. Then you have calculus, which is 4 marks we can consider, or sometimes 2, sometimes 5. So let's consider it an average of 4 marks. So this is the total weightage that is given for all the subjects. Okay. Once we have understood all this, we'll quickly jump into the first chapter, that is ratios and proportions, indices, and logarithms. Okay. Yes. Since time was a constraint for us in the examination, my approach would be to solve it in a way wherein you can finish or get the answer within the time frame that you have. See, you have 120 minutes in the exam, correct? You have 120 minutes in the exam. Here and there, if you consider 5 to 10 minutes, you will have to keep it as a buffer, because you cannot use the entire 120 minutes. So you have a little over a minute per question, correct? You have a little over a minute per question. So our target, wherever possible, should be that we need to solve a question within a minute or a maximum of a minute. Okay. One more important thing that I would like to share with you all, or want to tell you all as my opinion. See, don't go to spend a lot of time in one question. Do not spend a lot of time in one question. Okay. Do not, because the moment you spend more time in one question, you will start getting scared with respect to the time that you have left. So if you're not able to get the answer within maybe 2 minutes or 3 minutes, go to the next question, come to it later. So do not spend a lot of time in every question. All right, let us quickly start with the first chapter, that is ratios and proportions, indices and logarithms. How are we going to do this is, I explain all the concepts that is there in every chapter, and I've picked up a few questions from the past exam papers, which we will be solving. And here and there, when I am explaining the concepts to you, I'll definitely be giving you a few examples as well. Okay, so let's begin with the first topic, that is ratios. Now, what is a ratio? What is a ratio? In simple words, if I have to say, ratio is a comparison, correct? Comparison of what? Comparison, let us keep it as two quantities for now, okay? Yes, it is definitely a comparison of two or more quantities, yes. But the very important thing here is that the quantity should be of the same unit or kind. Now, what does this mean? What is this? The quantity should be of the same unit or kind. Now, for example, if I have to prepare, let's say, lime soda, correct? Okay. So if you have to prepare lime soda, what do you add? You have a concentrate in a glass, correct? In a glass, you'll have a concentrate. And for that, you will add soda to it. So what do you have here? You have concentrate and soda. Now, both these quantities can be measured in terms of milliliters, ml, correct? Both these quantities can be measured in terms of milliliters. But if I consider milliliters and if I consider kgs, can I have a meaningful comparison? Definitely not. To understand this better, let us take one more example. Let's say there are two people, okay? A and B, okay? A's height is 6 feet and B's height is 5 feet. A's height is 6 feet and B's height is 5 feet. Now, with comparing A and B, can I say A is taller than B? Possible? Can I say B is shorter than A? Okay. But if I take A's height, that is 6 feet, and B's weight, not height, weight, that is, let's say 50 kgs. Okay. So A's height 6 feet and B's weight 50 kgs. Can I have a meaningful comparison? Definitely not. Why is that? Because the quantities are the units. The units of the quantities are different. What are we doing here? We cannot compare when the units are different. So when can you have a ratio? You can only have a ratio that is a meaningful comparison when the quantities are of the same unit or same type. All right. Now, moving on. Let's understand how to represent a ratio or how to write a ratio. So if the two quantities are A and B, let us say the two quantities are A and B. So this A and B, the two quantities of the ratio, which are of the same kind or unit, can be denoted as A is to B or A divided by B. So you can denote it as A is to B or A divided by B. In the example that I took, 6 feet and 5 feet, correct? I said ratio of A to B, correct? Ratio of A to B. So 6 feet to 5 feet, you can write it as 6 is to 5. Or you can also write it as 6 by 5. So this is your basic of a ratio. So now, very important to understand here, it is the ratio of A to B, which is denoted as A is to B. Okay. So here the order is important, which means A is to B or A to B is not the same as B to A or B is to A. What is it? We will understand it a little later. Okay. So now here, let's say we have two quantities, A and B. We have two quantities, A and B. So these A and B are called the terms of the ratio, okay, where A is called the antecedent. A is called the antecedent. Please repeat after me. It becomes a revision for you all. And B is called the consequent, okay. A is called the antecedent, B is called the consequent. They can also be called as first term and second term of the ratio. The important words here are antecedent, that is first term, that is A, consequent, that is second term, that is B. Okay. All right. Moving ahead, let's understand a few notes which we have already discussed. Okay. The quantities of the ratio should be of the same kind or unit. The example I've given you just now, that is height of A, can be compared with height of B, correct? But height of A compared with weight of B is not meaningful, which we have already understood. Moving on to the next note, which is the order of the terms of the ratio is important, which means A is to B is not the same as B is to A. The same thing I had explained it to you. Okay. Moving on to the next note, which is both the terms of the ratio, right? That is A and B. Both the terms of the ratio can be multiplied or divided by the same number except 0. Okay. Both the terms. So you cannot be partial here. I like the first term, so I will only multiply the first term. I do not like the second term, so I will not multiply it with any number. No, that is not the case. Both the terms. So now here I've given you an example, right? 30 by 150, which can also be written as 30 is to 150. Now this 30 and 150, can you simplify it? Of course you can simplify it. How? You can divide them by both the numbers by 30, correct? 30 ones are 30 and 30 fives are 150, correct? Yes. So both the numbers can be divided by 30, making it 1 by 5, or you can also write this as 1 is to 5. Is this clear till here? Yes. So what are we doing here? We have simplified the ratio, correct? 30 by 150 has become 1 by 5, or 1 is to 5. Now, the next example that we have taken over here. Now, the first example we have understood with respect to divided by. Now, in the second example, let us understand with respect to multiplication or multiplied. Now, see here, 2 by 3. Okay, what is the ratio? The ratio is 2 by 3. 2 by 3 has become 8 by what? Okay, I have not given you the consequent there, correct? I've given you the antecedent, which is 8. So what is the corresponding consequent? Now, 2 has become 8. How can 2 become 8? Only when you multiplied 2 with 4, correct? Now, just now I told you, you cannot be partial. You cannot only multiply the numerator or the antecedent, you also have to multiply the consequent, which means you have to divide it by 4 as well. Yes. So what is this? 3 into 4. 3 fours are 12. So can I say the ratio is 8 by 12, or the consequent that we are supposed to find out is this clear till here? Okay. And the last point, which is very simple thing, that is a ratio is usually expressed in the most simplified form. So what is this simplified form? See here in example A, correct? In example A, what is that example? 30 by 150. What was the 30 by 150? We simplified it and we got it as 1 is to 5. So can we simplify it even further? No, not possible. Always remember that when it is a ratio, it should always be two quantities, A is to B. To make you clear about it, see, for example, if we have a ratio as 3 by, okay, 3 by 1, you cannot write this as 3. It is not a number. It is not a fraction 3 by 1. Okay. It is a ratio 3 by 1. So you cannot write it as 3. This becomes 3 is to 1. Okay. This is very important to understand. All right. So with this, we are done with the basics of ratios. Now let us move on to what are the types of ratios? Okay. Very simple. Let's quickly understand the first 4 simple types of ratios. First one is duplicate ratio of A is to B. What is duplicate? Duplicate is the same thing again. So duplicate ratio of A is to B is A square is to B square. So if I ask you, what is the duplicate of 2 is to 3? You will give me the answer as 4 is to 9. Correct? Yes? Okay. Next, triplicate ratio. Duplicate is square, triplicate is cube. So if I ask you what is the triplicate of 2 is to 3, you will give the answer as 8 is to 27. Okay. Next one is subduplicate ratio. Now what is this subduplicate ratio? Duplicate is square, subduplicate square root. Okay. So what is the subduplicate of 16 is to 9? That becomes 4 is to 3. Square root of 16 is 4 and square root of 9 is 3. So that becomes 4 is to 3. Now next, what is the subtriplicate ratio? Subduplicate is square root. So subtriplicate will be cube root. So what is the subtriplicate ratio of, let's say, 27 is to 64? Okay. Cube root of 27 is 3 and cube root of 64 is 4. Okay. So these are your first 4 types of ratios: duplicate ratio, triplicate ratio, subduplicate ratio, and subtriplicate ratio. Okay. Now, in the exam, write direct questions on this will not be asked, but it will be asked with something else. When I say something else, like for example, the next concept, that is compounded ratio. Now, what is this compounded ratio? Now, to find compounded ratios, okay, to find a compounded ratio, you should have more than one ratio. Okay, you should have more than one ratio. Only if you have more than one ratio is when you can find a compounded ratio. So now what do you do in compounded ratio? Now let's say we have A is to B and C is to D. We have 2 ratios, right? A is to B and C is to D. Now in these 2 ratios, in the first ratio, A is the antecedent. In the second ratio, C is the antecedent. Correct? Okay. So what do we do in compounded ratio? We simply multiply the antecedents. Okay? Is to, we multiply the consequent. So what do you get here? You get AC is to BD. All right. To understand this better, let us take an example. All right. Okay. So first example, I've taken a few examples here. Let's understand the first example. Find the compounded ratio of 2 is to 3, 4 is to 6, and 9 is to 1. Okay. I would always suggest you, when you're finding compounded ratio or when you're solving any questions of ratios, you always write it in the form of A by B, not A is to B. Okay. It becomes easier for you to solve if you write it in the form of A by. All right. So to find the compounded ratio, how many ratios are there here? We have 3 ratios altogether. Okay, let us write it: 2 by 3 into 4 by 6 into 9 by 1. Okay. Now, can we simplify this? Of course, yes. 3 ones are 3 threes are 9. 3 ones are 3 twos are 6. And 2 ones are 2 twos are. So what you get is 4 by 1. Or you can also write it as 4 is to 1. Okay. This is your compounded ratio. I'll do one more example. And then we have a third example, which I think you can quickly solve it. All right. Yes. Second example. Find the compounded ratio of 2 is to 3. Duplicate ratio of 3 is to 2. Duplicate of 3 is to 2. So what is duplicate now? Duplicate is squaring both the terms. So you get 3 square, that is 9, and 2 square, that is 4. And 4 is to 9. Now, there could be a confusion here. Okay. What is that confusion? The confusion could be, is duplicate applicable to 4 by 9 or is it only applicable to 3 is to 2? Okay. So what is the confusion? It could be, is duplicate applicable to 4 by 9? No. Duplicate is not applicable to 4 by 9 because this and is given to end the sentence, to complete the sentence. It is a grammatical way of writing, right? So when you say 2, 3, 4, and 5. When you have to stop or when you have to end it, you will say and 5. So that is this and over here. So you take 4 by 9 as it is. Okay. So now 9 ones are 9 ones are, 4 ones are 4 ones are. So what remains is 2 into 1 into 1, which is 2, divided by 3 into 1 into 1, which is 3. So the answer is 2:3. Okay. Is this clear till? Yeah. Now quickly solve the third one. I'll give you a minute time. Quickly solve the third one. And if you have any doubts, kindly drop it on the live chat so that I can answer them. I hope you all got the answer as 16 by 189. Correct? If you have any doubts, kindly drop the doubts so that I can answer them. Yes. Yes, Disha. Correct. It is 16 by 189. Good. Yes. So can we go ahead with the next concept? That is the next type of ratio, which is called the inverse ratio of A is to B. If you remember, I had mentioned this to you all in the beginning that the order of the ratio is important, correct? And I also told you that A is to B is not the same as B is to A. So what is this B is to A now? B is to A is nothing but the inverse of A is to B. So let's say we have a ratio 2:3. Okay, this is the ratio 2:3. Now what is this inverse of 2:3? The inverse ratio of 2:3 is 3:2, which means 2:3 and 3:2 is not the same. Okay, 2:3 and 3:2 is not the same. So what is what is the inverse of 2:3? That is 3:2. Okay, next simple one, which is the ratio of greater inequality and lesser inequality. Now, what is this ratio of greater inequality and lesser inequality? Now, we say a ratio is of greater inequality when A, that is the antecedent, is value of antecedent is higher than the value of the consequent. Okay, and we say that a ratio is of lesser inequality when the value of antecedent is lesser than the value of consequent. I hope that you know that this symbol is greater than and this symbol is lesser than. Okay, so wherever the symbol has an open mouth, that side is greater than, and wherever the symbol has a closed mouth, that side is lesser than. Okay, this is how you need to remember things. Okay, yes. So now let's take an example. First one. Okay, in the first one, what is the first one? 4/3, right? 4/3. Now, can I say in this case, in the first one, 4 is greater than 3, which means antecedent is greater than the consequent, which means that this is a ratio of greater inequality, correct? And in the second one, that is 2 by 9, 2 is less than 9, which means A is less than B, which means that this is lesser inequality. Okay, this is a very simple topic that you need to know, but you never know what if you don't study it and it turns up in the exam. Okay, we're very lucky that way, right? So whatever we don't study might turn up in the exam. So you have to study everything that is possible from your side. Okay, next one and the last concept under ratio, that is the continued ratio. Okay, so what is this continued ratio? So till now, if you remember, we had studied a ratio of two quantities, A, B, A, B, A, B. That's it. But if you go back to the first explanation or the meaning of ratio, I said ratio is a comparison of two or more quantities. And I also told you that right now I'll stick to two quantities, but at the end, after some time, we will understand what is this two or more quantities. Okay. Is it compulsory that a ratio can be expressed only of two quantities? Definitely not. Because take an example of your partnership problems, okay? In accounts, there you have something called as profit or loss sharing ratio. That is also a ratio. If you remember it, in there, what you have is you can have two partners or more than two partners. You still write it as a ratio itself, correct? So when you talk about ratio, it can be more than two quantities. Okay, it can be more than two quantities, and that is what is called a continued ratio. Okay. Now, in continued ratio, I want us to understand this particular example. Okay. So now what is this given as? It is given that A by B is equal to 2 by 5 and B by C is equal to 4 by 3. Okay. What is given? A by B is equal to 2 by 5 and B by C is equal to 4 by 3. Two different ratios and values are given. Okay. Now, what do I need to find here? What do I want you to find here is I want you to find the value of or the ratio of, I want you to find the ratio of A is to B is to C. Okay. What are we supposed to find here? Ratio of A is to B is to C. How do we do this? How do we get the ratio of A is to B is to C? Can you randomly write the values? A is to B is 5, C is 3. Or A is to B is 4. I like the number 4, so I'm going to write 4. And C is 3. Definitely. So how do we write it down? How do we get a continued ratio of three particular things? Now, very important to understand here is that the term B is common in both the ratios. It's there in A by B as well as in B by C, correct? It's there in A by B as well as in B by C. So what is the common term here? Common term is. So what do you need to understand here is your first step is to make the value of the common term same. Okay? You need to make the value of the common term same. How do we do it? It's a very simple thing. Multiply the first ratio with the value of B of the second ratio. Multiply the first ratio with the value of B of the second ratio and multiply the second ratio with the value of B of the first ratio. Okay. And when you multiply this, you'll get 2 4s are 8, 4 5s are 5 4s are 20. And here you will get 4 5s are 20, 3 5s are. This is what you will get. Okay. I hope this is clear till here. If you have any doubts, please drop in a message. Please drop in a message so that I get to know and your doubts are clarified. And by the end of the session, whatever topics are covered for the day, you should not go back home with doubts. You should go with the mindset that, okay, it's clear to me. Now I know that I need to solve more and more questions, practice more and more for the upcoming exams. All right. So now let's understand how to get the ratio of A is to B is to C. Like I told you some time ago that you need to make the value of B. Now that the value of B is same in both the ratios, you can directly extract the values. Okay, which means here you can write A as 8, B as 20, and C as 15. So this is how you get the continued ratio. Is this clear till here? Okay. With this, we are done with the concepts of ratios. Okay. So how are we going to cover this is, we'll do ratios, proportions, indices, logarithms, and we'll quickly pick up a few questions after the completion of chapter 1. Similarly, chapter 2, then questions, a few questions, okay? Then chapter 3 and so on. Okay. Moving on to proportion. Okay. So now what is a proportion? What is proportion? Okay. In simple words, if there are two ratios, A by B, C by D. Okay. There are two ratios. Okay. Now, if these two ratios are equal to each other, if these two ratios are equal to each other, then we say that they are in proportion to one another. Okay. So A, B, C, D. AB is one ratio, CD is the other ratios. If they are equal to each other, then we say that they are in proportion to one another. Okay. So we said A, B, C, D. So these four are the quantities. Okay. So these four are the quantities. And when they are in proportion, we write it as A is to B is equal to C is to. Okay. Now focus only on how it is denoted. Don't focus on the other things. So what do we write it as? A is to B is equal to C is to D. Or A by B is equal to C by D. Okay. Or we can also write it as A to B as C to D. So these are the three ways in which a proportion is denoted. Okay. Now here A, B, C and D are called the proportionals. What are they called? They are called the proportionals. Okay. They are called the proportionals. A is the first proportional, B is the second proportional, C is the third proportional, D is the fourth proportional. Okay. So A being the first proportional, B second, C third, and D fourth. Remember this, very important. So what are they called? They are called proportionals. Now, they have been given another name. Okay. Another name, but a specific terms. What are they? Now, A and D. If you observe, they are at the end here. A and D. Okay. They are also called as extremes. What are they called? They are also called as extremes. Please repeat wherever you are, wherever you are listening from. Please repeat after me. It becomes a revision. Don't just listen to the class. Please repeat. Okay. So A and D are called extremes. Correct. And B and C are called the means or middle terms. Okay. A and D are called extremes. B and C are called means or middle terms. This is the basics of proportion that you need to know. Okay. Now next, what is this continued proportion? Continued proportion. What is this continued proportion? Okay. So what is continued proportion here? Continued proportion here is A by B is equal to B by C is equal to C by D and so on. So A by B is equal to B by C is equal to C by D and so on. Okay. So let's understand this. Let's take an example. Let's understand this. What is this? So here, if you observe carefully, there are more than two ratios. Correct? A by B is one ratio. B by C is one more ratio. C by D is another ratio. So A by B is one ratio. B by C is one more ratio. And C by D is another ratio. And if you observe carefully over here, in first ratio, the consequent has been repeated as the antecedent of the second ratio. And in the second ratio's consequent is been repeated as the antecedent in the third ratio. Okay. So this is your continued ratio, wherein the consequent of the first ratio is there in the antecedent of the second ratio, and so on and so forth. Okay. So continued ratio is A by B is equal to B by C is equal to C by D and so on. All right. Moving on. Next one, that is mean proportional. Okay. What is this mean proportional? Now let's say there are three terms. Okay. Three terms which are in proportion, but they are in continued proportion. Correct? To write them in a normal proportion, you need four terms. But To write them in a continued proportion, if you have 3 or more terms, it is enough. So let's say we have A, B, C, which are in continued proportion. All right. So now here, we can write this as A by B is equal to B by C. We can write this as A by B is equal to B by C. And you can cross multiply this, correct? You can cross multiply this. And when you cross multiply this, what do you get? You get B into B, which is B square, and A into C, which is AC. So B square is equal to AC, which becomes B is equal to root of AC. So what does it become? It becomes B is equal to root of AC. All right. So it becomes B is equal to root of AC. So here B becomes the mean proportional. What does B become? B becomes the mean proportional. Is this clear till here? What is normal proportion, what is a continued proportion, and what is a mean proportional? So the concept of mean proportional comes into picture when you have 3 terms in continued proportion. All right. Now that we've understood this, let's take a few examples to go through the get a clear knowledge about the concept. Now, first example that we have is find the mean proportional between 3 and 27. Find the mean proportional between 3 and 27. So how do you find the mean proportional? You write this as B square is equal to AC, correct? So what is B square? That is what we are supposed to find, which becomes our B. And this 3 and 27 are nothing but A and C. So B square can be written as 3 into 27. All right. B square can be written as 3 into 27, which becomes 81. And the square root of 81 is 9. So what is B? B is 9. Is this clear? I hope you know how to use square root on your calculators. Yes. Now, let's go to the next question, which is finding the fourth proportional between 2, 3, and 6. Okay. Now you have 3 things here, A, B, and C. You have to find the fourth proportional, which is nothing but B. So how do you write this? You write this as 2 by 3 is equal to 6 by D. You write it as 2 by 3 is equal to 6 by D. Now, the next step is to find the value of D. I hope you know how to cross multiply. You just have to multiply this D here and 3 with 6. So you get 2D is equal to 3 into 6 is 18, which means D is equal to 18 divided by 2. That is equal to 9. So the fourth proportional here becomes 9. Okay. Now that you've understood the first and the second example, I want you to try the third one on your own. Now, before you try the third one, be careful. See which concept is applicable there and then solve it. Okay. Please put your answers on the live chat so that even I get to know whether you're solving it or not. Okay. Oh, good. Nice. I've been getting answers on the live chat about the second one. Great. Third one, please solve it. Yes, can I get the answers? All right, let's solve it. What is this third proportional now? Okay, so if you clearly observe this, here in this particular question, they have given us two values, 4 and 16, correct? They've given us only two values, that is 4 and 16. Now, with the help of these two values, you have to find another value, which is the third proportional. First proportional is A, second proportional is B, third proportional is C, and fourth proportional is D. But can we use the normal proportion here? No, we cannot. Why? Because we have only been given two values, which means we have to use the concept of continued proportion. Okay, so how do we write this? We write this as 4 by 16 is equal to 16 divided by C. Why divided by C? Okay, because we have to find the value of C, that is the third proportional, and we have been given only two values, correct? So you have to find the value of the third proportional, and we have been given only two values, which means the first one becomes A, the second one becomes B. So A by B is equal to B by C. Now cross multiply this. What do you get? You get 16 into 16, that is 256, divided by 4, because you get 4C is equal to 16 into 16, 256, divided by 4. So the answer, that is C, is 64. Is this clear? Yes, good. Yes, I've been getting few answers on this live chat. Very good. Great. Yes, I hope it is clear. Remember this, when they give you three values, okay? When they give you three values in the question and you're supposed to find the fourth one, okay? The fourth one could be A, B, C, D, anything. First, second, third, fourth proportional. Then you have to use A by B is equal to C by D. But when they give you two values and you have to find the third one, okay? When they give you two values and you have to find the third one, then you're supposed to use A by B is equal to B by C. And in that also, if you're supposed to find the mean proportional, then you directly use B square is equal to AC, or B is equal to root of AC. Okay, is this clear? All right, let's go to the next. That is the properties of proportion. The first one, and the very simple one, which we have already known. We already know this. It's just nothing but cross multiplication. But it's a property given and we have to study it. So what is this first property? It is given as cross product rule. Okay. What is the first property? The first property is given as cross product rule, which in our words, okay, to keep it simple for us, we'll call it as cross multiplication. What do we call it as? We shall call it as cross multiplication. Okay, so we shall call it as cross multiplication. So what do we do here? It is nothing but A by B is equal to C by D. That is your proportion. We cross multiply this, simple. What do you get? AD is equal to BC. Okay. Now, if you remember, A and D are called extremes and B and C are called means, correct? So AD is equal to BC means the product of extremes, that is A into D, product of extremes is equal to product of means. So what you need to understand here is, to check if four quantities are in proportion or not, you just have to multiply the extremes and the means. So if the product of extremes and the product of means are equal to each other, then they are said to be in proportion to one another. A simple example, let us take 2 by 3 is equal to 4 by 6. Okay, 2 by 3 is equal to 4 by 6. Now, are they in proportion? Let's check. Let's cross multiply. 2 into 6 is 12 and 3 into 4 is also 12, which means that they are in proportion, as simple as this. Okay. All right. Next particular property that we have is alternando. Now, what is this alternando? Okay. What is this property alternando? Simple word, alternate. What is it? Alternate. Okay. What is alternando? Alternate. Alternate what? Alternate way in which you can write a proportion. So if the proportion is given as A by B is equal to C by D, so this can also be written as A by C is equal to B by D. It will still be in proportion. Let us take an example and understand this here. 2 by 3 is equal to 4 by 6 can also be written as 2 by 4 is equal to 3 by 6. Just cross multiply. You will still get 12 is equal to 12. So this is nothing but your alternando property, or in our simple words, we can also say that it is excuse me. In our simple words, we can also say that it is alternate. Now, from examination point of view, alternando is important. Okay. From exam point of view, alternando is important. All right. Now, next particular property, that is invertendo. Invertendo. Now, invertendo, in simple words, I'll say it is inverse. Inverse. Ulta. Okay. So what is this inverse? See, A by B is equal to C by D can also be written as B by A is equal to D by C. B by A is equal to D by C. Still you'll get the same answer. Still you'll get the ratios in proportion to one another. Let us understand with the help of this example. So 2 by 3 is equal to 4 by 6 can be written as 3 by 2 is equal to 6 by 4. Correct? And when you cross multiply this, you'll get 3 4s are 12 and 2 into 6 is also 12. So this is your invertendo property. Okay, moving on. Next one, which is componendo. So what do you do under componendo? Under componendo, you simply add 1 on both the sides. What do you do under componendo? You add 1 on both the sides. Okay, so let's see what happens when we add 1 on both the sides. We get A by B plus 1 is equal to C by D plus 1. Okay, and if you take a common denominator here, you will get A plus B whole divided by B. Correct? Yes, I hope you know how to take a common denominator. Yes, you have taken the denominator as B for both the terms. So when you take the denominator as B for 1, you have to multiply the numerator also with B, because for 1, there is no denominator right now. The denominator is 1. Okay, is equal to C plus D whole divided by. So this is your componendo rule. Okay, so what is this? This is your componendo rule. Let us understand this with the help of the example. So in componendo, what happens? You will get 2 plus 3 whole divided by 3 is equal to 4 plus 6 whole divided by 6. So what answer do you get here? 2 plus 3 is 5. 5 by 3. 4 plus 6 is 10. 10 by 6. Cross multiply this. You will get 6 into 5, that is 30. And 3 into 10, that is also equal to 30. So you get 30 is to 30, which means they are in proportion to one another. Okay. Now, next that we have is the dividendo rule or dividendo concept, dividendo property, which is subtract 1. Okay. So in componendo, what did we do? We did add 1 on both sides. Here we are doing subtracting 1 on both the sides. Okay. So A by B minus 1, C by D minus 1. So what do you get? A minus B whole divided by B is equal to C minus D whole divided by. Okay. Now, moving ahead, let's understand the example here. So you get 2 minus 3 whole divided by 3. And here 4 minus 6 whole divided by 6. If you solve this, you'll get minus 1 by 3 is equal to minus 2 by 6. Cross multiply this. Minus minus you can cancel. You will get 6 is equal to 6, which means they are in proportion to one another. This is your dividendo property. Next, componendo and dividendo. In simple words, if I have to say, this is componendo divided by dividendo. Componendo divided by dividendo. Now remember, there is nothing called dividendo by componendo. Okay. There is nothing called dividendo by componendo. It is only componendo by dividendo. Okay. So what do you get here? What is your componendo rule? It is A plus B by B, C plus D by, now this divided by A minus B by B is equal to C minus D by D. Okay. So here B and B, that is denominators of the terms gets cancelled, and denominators here also will get cancelled. Ultimately, what remains is A plus B by A minus B is equal to C plus D by C minus D. This is your componendo and dividendo rule. Okay. Example, if I have to take 2 plus 3 by 2 minus 3, 4 plus 6 by 4 minus 6. So you get 5 by minus 1 is equal to 10 by minus 2. If you cross multiply, you will get 10 is equal to 10 minus 10 is equal to minus 10, which means 10 is equal to 10. Okay, this is your componendo and dividendo. The last two properties, addendo and subtrahendo. Okay, now addendo. If you understand addendo, you can quickly understand subtrahendo. There is nothing difficult there. Okay. So now what is this addendo? Let's say we have three ratios, A by B, C by D, and E by F, which are in proportion to one another. It can be 3 or it can be more than 3 or it can be 2 or as well. So there's no compulsion as such. So it can be 2 or more ratios. I've considered 3 here. Okay. A by B, C by D, E by F. So they are in proportion to one another. Then if these three ratios are in proportion to one another, then each of these ratios will be in proportion to A plus C plus E and so on, divided by B plus D plus F plus so on. What is this? Okay. How do you understand this? Let us take an example. We have, let's say, 2 by 3, 4 by 6, and 8 by 12. Three ratios which are in proportion to one another. So what have we done in addendo? We have to add all the antecedents. What should you do in addendo? We have to add all the antecedents. Okay. Okay, let's add all the antecedents. You will get 2 plus 4 plus 8 divided by, add all the consequence. What do you get? 3 plus 6 plus 12. So you get 14 by 21, right? You get 14 by 21. Am I right? Yes. Now this 14 by 21 can be simplified and divided by 7, and we can write this as 2 by 3. Correct? We can write this as 2 by 3. And if you observe, this 2 by 3 is in proportion to all of these three ratios. That is 2 by 3 and 2 by 3 are equal. 2 by 3 and 4 by 6 are equal. 2 by 3 and 8 by 12 are equal, which means we can write this as 2 by 3 is equal to 2 by 3. 2 by 3 is equal to 4 by 6. And also 2 by 3 is equal to 8 by 12. Now this is what it means. I hope it is clear. Okay. So 2 by 3 equal to each other. 2 by 3 and 4 by 6 are also equal to each other. Similarly, 2 by 3 and 8 by 12 are also equal to each other. Is it clear till here, everyone? Okay. All right. Now, subtrahendo. What is subtrahendo? It is similar to addendo, but instead of adding, you are subtracting here. That's all. Instead of adding A plus C plus E, you will do A minus C minus E and B minus D minus F. Is this clear? Yes, everyone? All right. So now example here. Let's say 2 minus 4 minus 8 divided by 3 minus 6 minus 12. Correct? So what do you get here? 2 minus 4 minus 8 is minus 10 divided by 3 minus 6 minus 12 is minus 15. Minus minus gets cancelled. Both are divisible by 5. So you get 2 by 3, which again are in proportion to 2 by 3, 4 by 6 and 8 by 3. Okay. With this, we are done with the proportions. I hope it is clear to you all. what types of proportions, properties of proportions, and the types of ratios that we have covered until now. Now, moving on, which is the next concept, that is the concept of indices. Okay, now, excuse me. Okay, concept of indices. Now, what is this indices? If you've studied this before, you might have some kind of a pre-notion about the chapter. Don't keep it in your mind. Consider this as one of the simple topics. Okay, if you clearly understand the laws of indices, if you clearly understand the law that we're going to study, it becomes easier for you to solve. Okay, so give your 100% attention when we're doing the laws of indices. Okay, now indices, that is the plural of the word index. Okay, so the singular form of the word indices is index. Now, what is this index? Index means the power of any number or any term for that matter. Now, if I say, for example, 2 to the power 3. Okay, 2 to the power 3. Now, here, 2 to the power 3, that is how we are explaining it, correct? That is how we tell it. And what is this 2 and what is this 3? 2 to the power 3 is the number or the term. In this case, 2 is your base. Okay, 2 is your base and 3 is the power, which is also called as index. Okay, 3 is the power, which is also called as index. All right. So now, for example, if we have a to the power x, okay, a to the power x. Now here, a is called the base of the term. A is called the base of the term and x is called the power or the index. X is called the power or the index. Is this clear till here? So what is any term which has a power, we can call it as the index of the term. So what we are going to study in this chapter, how to treat the powers, how to treat a number, how to treat when there are more than one powers for different numbers. When the terms are multiplied, when should we add them, when should we divide them, and so on. And I would like to tell you that this is one of the topics, okay? This is one of the topics wherein the concepts that you're studying in this topic are there in other chapters also. For example, in time value of money, you will use power concepts. In geometric progressions, when we do, you will use the concepts of a to the power n or a to the power x. So this is one of the topics which is very, very important as a basics of the entire syllabus of mathematics. Okay. Now, quickly, let's go to the laws of indices. We will take one example for each law of indices and understand. All right. Yes. So the first law. Okay. What is the first law? The first law is given as a to the power m into a to the power n. What is this a to the power m into a to the power n? First of all, what you need to observe here is there are two terms, correct? What are the two terms? A to the power m, a to the power n. These are the two terms. Secondly, these two terms are multiplied with each other, correct? Third, if you observe, the base of the two terms are the same. That is a. The base of two terms are the same. That is a. So what happens here? See, when there are two terms which are multiplied with each other and their bases are the same. When those terms are multiplied with each other and their bases are the same, then the powers can be added. So what you get here is a to the power m plus n. Okay. Now, example 1. See, the examples are given for you to understand the law. All right. I know that you can directly multiply 16 and 32 and get the answer, but that is not our idea here. Our idea here is to understand the concept. Now, this 16 and 32. Okay. 16 and 32. Can we write them in terms of 2? Yes, of course, we can write them in terms of 2. Can write them in terms of any other number? No, but we can definitely write them in terms of 2. How do you write it in terms of 2? That is 16 is 2 to the power 4 and 32 is 2 to the power 5. Correct? Yes. Now, if you observe here, the base of these two terms are 2 and they are multiplied. So what can you do? You can simply add the powers. So what do you get? 2 to the power 4 plus 9, that 4 plus 5, that is 2 to the power 9. Is this clear till here? All right. Now, next example that I've taken here is a to the power 8 into a to the power 9 into a to the power 6. Now see here, in the law, we said 2 terms, correct? But is it important that we should always restrict to 2 terms? No. It can be more than 2 terms as well. Okay? It can be more than 2 terms as well. Okay, now here we have 3 terms. A to the power 8, a to the power 9 and a to the power 6. Okay, correct? A to the power 8, a to the power 9 and a to the power 6. So what happens here? We simply add this 8 plus 9 plus 6. 8 plus 9 is 17. 17 plus 6 is 23. So you get a to the power 23 as the answer. I hope this is clear. The first law is clear. Yes. Okay. First law is clear. We can move to the second law of indices. Okay. Now in the first law, what did we do? We said A into something. So product. And in the second law, it is division. So A to the power M divided by A to the power N. First things, 1. Base is same. Correct? A and A. Both the terms are having the same base. Second, the terms are divided by each other. In the first one, the terms were multiplied with each other. Correct? So when the terms were multiplied with each other, we added the powers. Now when the terms are divided by each other, we will subtract the power. Okay. But one important thing here is, it is power of the numerator minus the power of the denominator. Is this clear? Power of the numerator minus the power of the denominator. So if denominator has 2 terms, then minus is applicable to both. Okay, let's understand this. Now, 81 and 243 is given. So 81 divided by 243. Can I write 81 as 3 to the power 4 and 243 as 3 to the power 5. Correct? So what do you get? 3 to the power 4 minus 5. That is 3 to the power minus 1. Is this clear till here? Okay. Now next question. Next example. That is 2 to the power 4x plus 3 divided by 2 to the power x minus 1. Okay. Now the base is same. So I can write this as 2 to the power 4x plus 3 minus x minus 1. Is this the correct way of writing it? Definitely. Why? Because this minus is applicable to both the terms of the denominator. This is where most of them go wrong. Minus is applicable to both the terms of the denominator. Okay. So what you get here is 2 to the power 4x plus 3 minus x minus of minus 1, which is plus 1. This is clear till here? 4x plus 3 minus x plus 1. This is important to understand. From exam point of view, we get 2 to the power 4x minus x is 3x and 3 plus 1 is, so we get the answer as 3x plus 4. So things like this, simple things like this, where usually students make mistakes. So please be careful. All right, moving on, which is the next law, that is a into b whole to the power m. AB whole to the power m. Simple, you can just multiply both the terms with the power. So a to the power m into b to the power m. So in the example here, I can write this as 2 to the power 6 into x to the power 6, or x to the power 4 into x to the y to the power 4 can be written as xy to the power. What I'm trying to make you understand here is that it's not always the left hand side equal to right hand side. It can also be the right hand side equal to side. Remember this. Okay. In indices or any chapter, it is important for us to go from left side to right side as well as from right side to left side. Okay. Now, let's say we have 2 to the power 6 plus x to the power 6. Can we write this as 2 plus x whole to the power 6? Can we write this as 2 plus x whole to the power 6? If you're there, please answer in the chat. Can you write this as 2 plus x whole to the power 6? Yes or no? No. I got one answer. Sahana, no. Okay. Anyone else? Okay. Narayan, yes. All right. No. Yes, this is correct. It cannot be written as 2 plus x whole to the power 6. Reason is that here the two terms are added. They are added, not multiplied. Similarly, if it was 2 to the power 6, x to the power 6, then we could write this as 2x whole to the power 6. So the reason why we cannot take the power as common power outside is because there is a plus sign in between. Not because the bases are not equal. No, there is a plus sign in between. That is the reason why you cannot take the power outside. Is this clear? Yes? Okay. All right. Now, moving on to the next concept. In the previous one, we did AB whole to the power m. A into B whole to the power m. Here we are doing A divided by B whole to the power m. So what are we studying here? A divided by B whole to the power m. So which is A to the power m by B to the power m. Okay. All right. So here we can write this as 2 by y whole to the power 4. Similarly, 27 can be written as 3 to the power 3 and 8 can be written as 2 to the power 3, which can be written as 3 by 2 whole to the power 3. I hope this is clear. These are all very simple laws of indices. Yes. Moving on to the next one, which is mth root of a. Now, what is this mth root of a? Now, if I write root 2, what does this mean? This means that it is the square root of 2, correct? But if I write this as cube root of 2, what does this mean? This means that it is the cube root of 2. So there's a difference, right? Square root means 1 by 2 and cube root means 1 by 3. Now, what does this mean? 1 by 2 and 1 by 3. It means that this can also be written as 2 to the power 1 by 2. And this can also be written as 2 to the power 1 by 3. So the respective roots can be taken to the power and written as 1 divided by whatever is the value of the root. So here, mth root of a can also be written as a to the power 1 by m. Okay. Similarly, here 6 to the power 1 by 3. Okay. Cube root of 6 can be written as 6 to the power 1 by 3. And fourth root of 16 can be written as 16 to the power 1 by 4, which can be simplified as 16 is 2 to the power 4 to the power 1 by. Is this clear till here? Okay. Bringing us to the next property, which is a to the power m whole to the power n. A to the power m whole to the power n. That means the power is multiplied by another power. So in this case, m can be multiplied with n. So what do you get here? A to the power m whole to the power n becomes a to the power m into n, which can also be written as a to the power m n. Take an example here. 2 to the power x whole to the power 4. This x and 4 can be multiplied, which makes it 4x. This can be written as 2 to the power 4x. And if you come back to the previous example here, you have 2 to the power 4 into 1 by 4. 4 and 1 by 4 gets cancelled. So you get the answer as, hope this is clear till here. I hope there are no doubts until now. Okay, moving on to the next concept, that is the seventh one, which is a to the power 1 by m is equal to b. What is this a to the power 1 by m is equal to b? Now one term is equal to the other. And one of the terms here have a power. That is 1 by m. Okay, which is nothing but mth root of a. Okay, now you can simply shift this 1 by m from one side to the, remember this, when you shift the power from one side of the equality to the other, okay, from one side to the other, from the left hand to right hand or right hand to left hand, what happens is the power becomes the reciprocal of itself, which means 1 by m will become, so this can also be written as a is equal to b to the power. Okay, now let's take an example to understand this better. You have x to the power 3 is equal to 8. X to the power 3 is equal to 8. You have to find the value of x, which means this 3 should go to the other side. Only then you can find the value of x. So what do you get? X to the power 3 is equal to 8. Can I write 8 as, 1 minute. First, let us shift this 3. X is equal to 8 to the power 1 by, x is equal to 8 to the power 1 by 3, which can also be written as x is equal to 2 to the power 3 whole to the power 1 by 3. So 3 and 3 here gets cancelled. So what is the value of x? The value of x is 2. Is this clear till here? Okay, this is how you can use the property. Next, x to the power 3 is equal to 27 is given, correct? So we can write this as x is equal to 27 to the power 1 by 3, right? X is equal to 27 to the power 1 by 3. And this can also be written as x is equal to 3 to the power 3 whole to the power 1 by 3, making the answer x as 3. This is how you can use the law. All right, moving on to the next one, which is a to the power minus m. Now, a to the power minus m can also be written as 1 by a to the power m. A to the power minus m can also be written as 1 by a power m. Okay, very simple here. 2 to the power minus 3 can also be written as 1 by 2 power 3. Vice versa, which means if the power of a term is negative, the power of a term is negative, to remove the negative power, you need to take the reciprocal of the entire term. The power of a term is negative. To remove the negative power, you need to take the reciprocal of the entire term. So here, you have 1 by 3 to the power minus 2. 1 by 3 to the power minus 2. What is the reciprocal? 3 comes to the numerator, correct? 3 comes to the numerator. So when 3 comes to the numerator, the power minus 2 becomes positive. So what do you get here? 3 power. Is this clear till here? I hope so. Okay. Very simple things next. Anything to the power 0. Anything to the power 0 is 1. So if I say 5 to the power 0 is 1, k to the power 0 is 1, and so on. So anything to the power 0 is equal to 1. But what you need to remember here is that anything that is a cannot be 0. Anything that is a cannot be 0, which means 0 to the power 0 is not 1. 0 to the power 0 is not 1. 0 to the power 0 is not defined. Is this clear till here? All right. Now, 1 to the power anything. 1 to the power anything. 1 to the power 5, 1 to the power 10, 1 to the power 20, 1 to the power 30, 1 to the power 100, 1 to the power 0, 1 to the power 2000, 1 to the power 10,000, anything. 1 power anything is equal to 1. Is this clear? 1 to the power anything is equal to 1. Okay. What about 1 to the power a minus term? That is 1 to the power minus 4. 1 to the power minus 4 can be written as 1 by 1 to the power 4. Correct? How 1 by 1 to the power 4? If you take the reciprocal of the term, the minus sign becomes positive. Correct? Now, what is 1 by 1 to the power 4? What is the denominator? 1 power 4 is 1. So what is 1 by 1, which is also equal to 1? So literally A can be anything. It can be a positive number, it can be a negative number, it can be a fraction, anything. 1 to the power anything is equal to, is this clear till here? Everyone? 1 to the power 0 is 1. 1 to the power 6 is also 1. Okay. Last two laws of indices. And then we can do the identity. And then we'll do a few questions. And then we'll go to logarithms. Okay? Yes. Now, 11th one. A to the power m is equal to a to the power m. Now you saw multiplied by. You saw divided by also. But this is a little different. What is this? How is this different from the other laws? Here, you have two terms, a to the power m and a to the power n. Okay? And these two terms are equal to each other. Equal to each other. So when two terms who have the same base are equal to each other, then we can say that the powers are equal, which means m is equal to n. What is it? We can say that the powers are equal, or the base is equal to. How will this work? So what is this base is equal to 1? Base is equal to 1 means here our base is a is equal to 1. So what do you get? A to the power m is 1 to the power m. 1 to the power anything is 1. And secondly, a to the power m, n is equal to 1 to the power n. 1 to the power anything is equal to 1. So 1 is equal to 1. So two things you need to understand here. It is either the first one or the second one. It cannot be both. It is any one of these. First one or the second one. It cannot be both. Is this clear? First one or the second one. It cannot be both. Okay. So if the powers are equal, then the base is not equal to 1. Okay. If the base is equal to 1, the powers may not be equal. Is this clear till here? Okay. Let us take an example to understand this. Now, it is given that 16 is equal to 2 to the power x. 16 is equal to 2 power x. Now, what do you need to find? You need to find the value of x over here, right? To find the value of x, you need to get the base same because x is in the power of the term. So, how do you get the base same? You write 16 in terms of 2. Is it possible to write 16 in terms of 2? Yes, of course. 16 can be written as 2 to the power 4. So, this becomes 2 to the power 4 is equal to 2 to the power x. Now, since the base is same in both the cases, we can equate the powers and say x is equal to, yes, okay. So what are we doing here? We are equating the bases and we are saying that the powers are equal to each other. Okay, very similar to the previous law is the next one where the powers are equal, but the base is not the same. Okay, so it is given that a to the power m is equal to b to the power m. Okay, a to the power m is equal to b to the power m. So the powers are same, but the base a and b, they are different from each other. But when the powers are the same, even though the bases are different, we can equate the bases and we can say that here a is equal to, okay, what do we say here? A is equal to b. Also, we can have another interpretation here where we say that the power is equal to 0. Okay, what is this? Power is equal to 0. What is the power here? The power is m. So we'll consider m as 0. So when we consider m as 0, what do you get? A to the power 0, what is it? 1. B to the power 0, what is it? 1. So 1 is equal to 1. So like I told you in the previous law, it is either this or this. Any one of them will be applicable. Now, most of the cases, it is the first one that is applicable in both the cases. That is, powers are equal and bases are equal. It is the first one that we use in many of the cases. It's not just in this chapter. We're also going to see in, we are also going to see these concepts in GP as well as time value of money. All right. Let's take an example. We have x square is equal to 16. Now, can we write 16 in terms of something to the power 2? Yes, we can. Why power 2? Because if you write it in terms of power 2, only then the powers are the same. So how do you write this? X square is equal to 4 square. Correct? Now, since the powers are the same, we can equate the bases and say x is equal to. Hope this is clear. All right. So now moving on to the important identities here. Okay. We have around 7 identities that you need to study. Okay. The first one is a plus b the whole square, which is a square plus b square plus 2ab. The second one is a minus b the whole square, which is a square plus b square minus 2ab. The third one is a square minus b square, that is a plus b into a minus b. The fourth one is a plus b the whole cube, which is a cube plus b cube plus 3ab into a plus b. The fifth one is a minus b the whole cube, which is a cube minus b cube minus 3ab into a minus b. The sixth one is a cube plus b cube, which is a plus b into a square plus b square minus ab. And the last one, that is the seventh one, is a cube minus b cube, which is a minus b into a square plus b square plus ab. Of course, you need to remember this. Okay. How to use the identities, I'll teach you with the help of a question. Okay. We have few questions. We will learn how to use identities in that question itself. Okay. Before we go to logarithms, we'll quickly do the questions that we have for ratios, proportions, and indices. Question number 1. Here we have a bag has 105 coins containing 50 paise and 25 paise coins. So the number of coins in the bag are 105. Okay. Now, this is segregated into two types, 50 paise coins as well as 25 paise coins. The ratio of number of these coins is 4:3. Okay. The total value in the bag is. Okay. First of all, things given in the question. First thing that we have is number of coins, total number of coins, that is 105. Next, we know that the value per coin, 50 paise coins are there, 25 paise coins are there. Okay. Next, we have also been given the ratio of coins. What is this ratio? This ratio is 4:3, which means 4 parts are 50 paise coins and 3 parts are 25 paise coins, which means there are total 7 parts. 4 plus 3, 7 parts of 105. Okay. So now firstly, we'll write 50 paise and 25 paise, correct? 50 paise coins in the ratio of 4 and 25 paise coins in the ratio of 3. So total 7 parts. So now what do we do here is we divide 105 by 7, correct? We divide 105 by 7. When you divide 105 by 7, what do you get? 105 divided by 7 is 15, correct? You get the answer as 15. So here 15 into 4 and here it is 15 into 3. What is 15 into 4? 60. And what is 15 into 3? 15 into 3 is 45. Total is it 105? It should be 105. 60 plus 45 is equal to 105. Okay. Now we have got the number of coins. There are 60 50 paise coins and there are 45 25 paise coins. Now you need to find the value of the coins. How will you find the value of the coin? Value is nothing but total coins into the value per coin. Yes. So there are 60 50 paise coins, which makes it 60 into 0.5, that is 30 rupees. And there are 45 25 paise coins, which makes it 45 into 0.25, that is 11.25 rupees. So 30 plus 11.25 is 41. Yes, and if you see, this is December 21 attempt question. I've included almost exam oriented questions itself, the ones which have been asked in the exams, so that you will get a fair idea as to what can be covered. One more important thing that I would like to share and tell you all here is that See, whatever material you have been studying from right now, please study from that material and do these questions. Okay. So whatever material you have been studying from, be it the institute material or the material that you have been referring, please stick to those materials itself. In the last minute, please do not change your materials right now. So stick to those materials, do a few additional questions, do it from the institute material, the additional question bank, solve as much as possible, and always keep a time limit when you solve. Okay, always keep time, because if you're solving 100 questions, let's say, keep 2 hours. See how many you can solve within those 2 hours, and then you get to know how your preparations are going on. And there is no need to panic. There's no need to get scared. What if I don't clear? What if I don't clear? Don't keep all that in your mind. Just go with the flow. Study as much as possible. Revise the concept. Study. Okay, don't waste your time. All right. I hope this is clear. We go to the next question. In a certain business, A and B receive profit in a certain ratio. B and C receive profit in the same ratio. Okay. A and B receive profit in a certain ratio. And they have said B and C receive the profit in the same ratio. That means A and B and C have received the profit in the same ratio, which means they are in proportion to one another. Okay. Next, they say if A gets 1,600 and C gets 2,500. Okay. A gets 1,600 and C gets 2,500. Then how much does B get? Okay. Very good, Vinayak. Correct answer. So can I say you just have to apply mean proportional here? This is nothing but mean proportional. A by B is equal to B by C, right? So it is nothing but mean proportional. So directly multiply. What do you get? B square is equal to 1,600 into 1,600 into 2,500. How much do you get? You get 40 lakhs. Now apply square root there. Square root of 40 lakhs is 2,000, correct? Hope this is clear. Yes, this is a very simple question and this has been asked in the exams. Yes, Meghana, correct. Good. All right, let's go to the next question. Okay. Yes. Two numbers are in the ratio 3:4, correct? The difference between their squares is 28. Find the greater number. Okay, all right. Now, I would suggest you to pick the options and quickly solve this rather than substituting x and everything. Okay, so what will you do here is we'll quickly pick an option. Now, greater number is given in the options, right? Okay, let's pick option A, 12. If 12 is the greater number, can I say 12 is in 4 parts? Why? Because it's given that the numbers are in the ratio 3:4, correct? So 12 is in 4 parts, right? 12 is in 4 parts. So we'll write this as 12 by 4 into 3. Why 12 by 4 into 3? Because we are supposed to find the other number, right? So what is 12 by 4? 12 by 4 is 3, correct? Right? 12 by 4 is 3. 3 into 3 is 9. So the other number should be 9. Now what have they said? The difference of their squares is 28. Okay, so let's see. 12 square minus 9 square. What is 12 square? 12 into 12, which is 144, minus 9 square, 81. So what is 144 minus 81? It is 63. So can I say option A is not the answer? Yes, option A is not the answer. The reason is that you're not getting the difference as 28. Okay, so move on to the next option. What is the next option? Option B, that is 8. Now 8 is a larger number here. Yes, which is in 4 parts. Yes or no? 8 is the larger number here, which is in 4 parts. Now what you need to find is the smaller number, which is 8 by 4 into 3. That is equal to 6. Am I right? 8 by 4 into 3, that is equal to 6. Now find the difference of their squares. 8 square minus 6 square. What is 8 square? 64. And what is 6 square? 36. Yes, so 64 minus 36, you get the answer as 28. So can I say option B is your answer? Yes. Everyone, you can solve this using x also. You can take it as 3x and 4x. 4x square minus 3x square is equal to 28. That is also how you can solve this. Now, I would recommend you to solve it using the options, yes, rather than using the values as x, because it could be slightly confusing at sometimes when you use the value as x, especially for non-maths students. If you're a math student, then you can stick to x. But for non-math student, it's easier if you solve it without the usage of x, because that is what we always get scared of. The moment we see the term x being there, we're always like, okay, this is mathematics, so I don't want to solve this or something like that. No, what I would suggest you is pick the option, substitute, and go ahead. But important point here is when you substitute the options or when you do it using x, you have to interpret the question clearly. If you do not interpret it properly, that you can go wrong in both the places. All right. If 3x minus 2 and 5 by 5x plus 6 is the duplicate ratio of 2 by 3, then the value of x. Okay. Now here, can you tell me, duplicate means what? Square, correct? Okay. There are two ratios here. First one and the second one. The first one is 3x minus 2 by 5x plus 6. And the second one is 2 by 3. Okay. Simply tell me, okay, in the chart, if we have to square, the duplicate means square, correct? If you have to square the first one or the second one, which one should we square? Should we square the first one or should we square the second one? Are we supposed to square the first ratio or are we supposed to square the second ratio? Read the question carefully. Kindly answer. Anything, it's fine if it is wrong. It's fine if it is wrong. It's fine. Just give me some answers. Are we supposed to square the first one or the second? Duplicate ratio means squaring, right? So are we supposed to square the first ratio or the second ratio? Okay, fine. No one is giving any answers. So let me explain it to you. I think there's some confusion here. Okay, all right. So what is the meaning of duplicate here? Duplicate means squaring, right? Duplicate means squaring. Okay, duplicate ratio means squaring. Now tell me, okay. You will get the answer as duplicate ratio once you square some term, correct? Yes. Now, instead of keeping the values as it is, let us take a numerical value. Okay, here, yes, there is a numerical value. Now tell me, dash is the duplicate ratio of 2 by 3. If this is the question, dash is the duplicate ratio of 2 by 3. What is your answer here? 4 by 9, right? Yes or no? Only if you square 2 by 3, only if you square 2 by 3, that is where you will get the duplicate ratio, right? Yes. To get the duplicate ratio, you have to square some other ratio, correct? So here, if 3x minus 2 by 5x plus 6 is the duplicate ratio, it means that you had to square some other ratio. Am I right? You had to square some other ratio, which means that is 2 by 3. So here, you will have to square 2 by 3 to get the ratio as 2x minus 3x minus 2 by 5x plus 6. Correct, Neha? Correct. So it is 2 by 3. That is 2 square by 3 square is equal to 3x minus 2 by 5x plus 6. All right. So now what do we do here? 2 square is 4. 3 square is 9. 3x minus 2 by 5x plus 6. Cross multiply. 4 into 5, 20x plus 4. Six ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24 is equal to 3 into 9x, that is 18x, sorry, 27x minus 9 twos are 18, correct? Now get all the terms with constants on one side and the terms with x on the other. So you get 24 plus 18, that is when you shift one term from the one side of the equality to the other, the signs will change, correct? Plus becomes minus, minus becomes plus. So 24 plus 18 is 42, and here 27x minus 20x will become 7x. I hope this is clear. 42 by 7 is 6. So therefore, the value of x is equal to 6. This type of question has been asked in quite a few attempts. This duplicate, subduplicate, this is the duplicate of this ratio, this is the subduplicate of the other ratio. So these types of questions have been asked in few attempts. Yes, correct. Option B is the answer. If you have any doubts, kindly drop it in the chat box. Yes, I hope it is clear. We can go to the next question. All right. So it's given x is equal to y to the power a. It's an indices question. It's very clear. That's an indices question. X is equal to y to the power a. Y is equal to z to the power p, and z is equal to x to the power c. We need to find the value of a, b, c. Okay. Now, if you observe very carefully here, okay, a, b, and c are there in the powers, correct? And it is there in the powers of different terms. X is equal to, y is equal to, z is equal to. These are three different terms, correct? Yes, x is equal to, y is equal to, z is equal to. These are three different terms. So now, x is equal to y to the power a, y is equal to z to the power b, and z is equal to x to the power c. How do you solve this? First, in such question, simply take the value, first value that you have. What is it? X is equal to y power a. Take the first value that you have. X is equal to y power a. Okay. Now next, what do you do? Okay. Check if the other term, that is y, is given in respect to any other of the two terms. Now, if you observe carefully here, It's given y is equal to z to the power b. Y is equal to z power b. Okay, so what do? You substitute the value of y as z to the power b. So you get x is equal to z to the power b to the power a. Correct? What we have done here is, in the place of y, we have substituted z power b. Okay. Now, you need a is there, b is there, you need c. Z can be substituted as x to the power c. Z can be substituted as x to the power c. So we can write this as x is equal to x to the power c to the power b, and a can be multiplied. Correct? Remember the law. A to the power m whole to the power n can be written as a to the power mn. So same thing, b into a can be written as ab. Okay. Now, before we go ahead, something very important and something very to keep it simple in your exams. So whenever you have two alphabets or two or more alphabets which are multiplied with each other, whenever you have two or more alphabets which are multiplied with each other, I would suggest you to keep it in the alphabetical order. Okay? Because see here, a into b or be it b into a, the value is the same. Okay? Like I say 2 into 3 or 3 into 2. The value is 6 itself, correct? But writing it as a into b makes it easier for you. Okay? Writing it as a into b makes it easier for you. All right? So now here, can I write this as x is equal to x to the power abc? Okay. Now, on the left hand side, you have x. On the left hand side, you have x, which means it is x to the power 1, right? When nothing is given in the power, it means that the power is 1, not 0. Okay, not 0, it is 1. So now, can I use the law of indices and say, when the base is same, x, and the terms are equal to each other, x to the power 1 is equal to x to the power abc, then we can say that the powers are equal, which means that abc is equal to, yes, very good, Adil, correct. Answer is 1. This is also an important question. Yes, this is called cyclical order question. Okay, this is called a cyclical order question. All right. Yes, I hope this is clear. Next question. Root 9. Can I write root 9 as 3? Of course, yes. Root 9 can be written as 3. So this is 3 to the power minus 8 into root 3. Can I write root 3 as 3 to the power 1 by 2? Root 3 as 3 power 1 by 2. So you get 3 to the power 1 by 2 whole to the power minus 5 is equal to 3 power a. You have to find the value of a here, which means you have to equate the bases. Both the bases should be equal to 3. Okay. We get 3 to the power minus 8 into 3 to the power minus 5 by 2 is equal to 3 to the power. Now on the left hand side, we have two terms which have the same base and they are multiplied with each other. So we shall add the powers. Now when you add the powers, don't change the sign. Okay. So this is 3 to the power minus 8 minus 5 by 2, because plus into minus is minus, is equal to 3 power a. Now this becomes 3 to the power 8 2 is a 16 minus 5 whole divided by 2 is equal to 3 power a. Minus 16 minus 5. Minus 16 minus 5 is minus 21 by 2. So 3 to the power minus 21 by 2 is equal to 3 to the power a. Bases are same. We can equate the powers. Therefore, we can say that minus 21 by 2 is equal to a, or a is equal to minus 21 by, yes, which is option C. Be careful with minus signs. Yes, be very careful when there are minus signs. Again, this is a June 22 exam question. I hope this is clear. Any doubts? Please ask. Yes, let's go to the next question now. It's given 3a by 2b whole to the power 2x minus 4 is equal to 2b by 3a whole to the power 2x minus 4. If you observe carefully, there are two terms, correct? In the two terms, that is the base, they are reciprocals of each other. Only the base. I'm only talking about the base right now. They're reciprocal of each other. Okay. So what you need to do is, one thing that you can do here is, you can make the base same. How can you make the base same is, you just have to take the reciprocal of one of the terms. Okay. So first term, let's keep it as it is. That is, we have 3a by 2b whole to the power 2x minus 4. Okay. Is equal to, I'll take the reciprocal of the second term. Okay. So you get 3a by 2b. Now remember, when you take the reciprocal of any term, the power changes its sign. Okay. So from plus it becomes minus, or from minus it becomes plus. Now here you have 2x minus 4. So this becomes minus of 2x minus 4. Remember again, the minus sign is applicable to both the terms, that is 2x as well as minus 4. Okay. Now, since the base is same, 3a by 2b, 3a by 2b, we can equate the powers. When the bases are same, the powers are equal to each other. Correct? When the bases are same, the powers are equal to each other. So what do we get here? We get 2x minus 4 is equal to 2x minus 4 is equal to minus 2x plus 4. Okay, get the terms with x on one side and constants on the other. 2x minus 2x, when you get it to the other side, it becomes plus 2x. So 2x plus 2x is 4x, and here 4 plus 4 is 8. So can I say the value of x is a very simple solution, but to get the solution, you need to know the laws of indices carefully. Yes, correct. Yes, Pranvi, correct. Yes, I hope this is clear. Let's go to the next question. And that will be the last question for indices. Then we'll come to the concepts of logarithms and continue with the questions. Okay. Yes. Okay. It's given xy plus yz plus zx is equal to minus 1. Okay. And they have asked us to find the value of x plus y by 1 plus xy, z plus y by 1 plus zy, and plus x plus z by 1 plus xz. All right. Now, what you need to do here is, you can't take a common denominator of the term because there are three different denominators given there, correct? The denominators are different from each other. Okay. So how do we start this? If you observe carefully, they have given us the value of minus 1. Okay. And in the question, they have given us 1 plus. Right? Now, if you simply shift this minus sign to the other side, if you simply shift the minus sign to the other side, can I say you will get minus xy minus yz plus zx is equal to 1. And in the place of 1 here, you can substitute this value. So by doing this, we get x by y divided by minus xy minus yz. Sorry, here it is. Minus zx plus xy. Correct? Plus, observe carefully, z by y divided by minus xy minus yz minus zx plus zy plus x plus z divided by minus xy minus yz minus zx plus xz. Okay. Now, come to the first value. Observe the first value carefully. You have minus xy plus xy, which makes it 0. 0. You can cancel it, correct? So what remains? What remains is x plus y divided by minus yz minus xz. I'll write it as xz instead of zx. Yes, in the alphabetical order, it becomes easier for us. Plus z by y as it is. In the denominator, minus yz and plus zy gets cancelled. Plus and minus makes it 0. What remains? Minus xy minus xz. Correct? Next term. Plus xz as it is divided by what remains? Minus zx plus xz gets cancelled. See, that is the reason I told you write it in the alphabetical order. See, if you write this in the alphabetical order, you know it clearly. Okay, this and this can be cancelled. The reason I have not written this in alphabetical order is to make you realize that if you write it in alphabetical order, it becomes easier for you to cancel things. Okay, so minus xy minus yz. Okay, now in the first denominator, can I say z is common? Minus z, I'll take it outside. Okay, so what remains is x plus y divided by minus z into y plus x. Now tell me one thing. 2 plus 3 is 5. 3 plus 2 is also 5, right? So can I cancel this and say 1 za 1 za? What remains is 1 by minus z. Correct? Plus z plus y as it is, whole divided by, what can you take common here? Minus x can be taken outside. What remains? Y plus z. Z plus y plus z is nothing but the same. So what happens? Here you get plus 1 by minus x. Next, plus x plus z whole divided by, what can you take outside? Minus y. What remains? X plus z. X plus z gets cancelled. What remains is minus 1 by minus y. Okay. You can write this as minus 1 by z minus 1 by y. X minus 1 by y. Take the common denominator as x into y into z. Now in the first term, numerator needs to be multiplied with x and y. So minus xy. The second term, numerator needs to be multiplied with y and z. So minus yz. And the third term, numerator needs to be multiplied with x and so minus xz. Now if you observe what is given in the question, it is, see here, minus xy minus yz minus zx, which is nothing but 1. So answer is 1 divided by x into y into z. Yes, I know that this is a little lengthier, agreed, but there are few questions which can be solved within a minute. So there will definitely be a few questions which needs a little more time. Okay, yes. So I hope this is clear. If you have any doubts, kindly ask. Yes, let's go to the. Okay, this becomes your last question. So let's continue with the concepts of logarithms, quickly understand the concepts of logarithms, and then get back to the questions. All right. So now what is a form of a logarithm? Before we get into the form of a logarithm, why is logarithms used? Logarithms is used to actually simplify calculations. Okay. The purpose of using logarithms is to simplify any calculations, especially when there is a power. Okay. So now what is the form of a logarithm? The form of a logarithm is given as log b base a is equal to x. Okay. Which means it can also be written by removing the log as a to the power x is equal to b. All right. Now see this example here. We have 2 to the power 3 is equal to x. Now this 2 to the power 3 is in the form of a to the power x is equal to b. Now this can also be written as log b base a is equal to x, which means log 8 base 2 is equal to 3. Sorry. Log 8 base 2 is equal to 3. This is your general form of a logarithm. Okay. Trust me, logarithms is 2 marks usually in the exams, and it is not difficult to score if you understand the concepts well. Okay. Please do not skip this chapter. It's one easy topic that you have to study. It's not as difficult as you think it is. So please do not skip the chapter. Okay. I'll teach you one method wherein you can find the value of log of any number by using the calculator. You don't have to use the properties. You can just use the calculator to find the log of a number. Okay. Now, before we get into the properties of logarithm, something that you need to understand here is with respect to the base. Now, here I have given the base as a, correct? Correct. A is the base. Now, there are 2 types that is possible. Okay. One is natural logarithm and the other one is common logarithm. Okay. One is natural logarithm and the other one is common logarithm. What is important for us in the exam is the common logarithm where the base is 10. Okay. Natural logarithm where the base is e. Now, this is not important from exam point of view. What is important for us is natural logarithm where the base is 10. So, any particular question where base is not given, we will always consider the base as 10. Okay. Yes. All right. Let's say we have 2 log values. Log a plus log b. Now here, I have not given you the base, which means that the base is same. So log a plus log b is equal to what? Log a into b. Okay. Log a plus log b is equal to log ab. How do we write this? This can be written as log 2 plus log 3 is equal to log 2 into 3. What is it? Log 2 plus log 3 is log 2 into 3. That is equal to log 6. As simple as this. Now, important here that you need to understand is this is not the same as log a plus b. Log a plus b. B does not have log. Log of a plus b. That means log is common for a and b. And one more, log a into log b. So these 3 are not the same as the above. What is the above? Log a plus log b. Okay, next. Log a minus log b. If log a plus log b was log ab, then log a minus log b is log a by b. Okay. So log 16 minus log 2 can be written as log 16 divided by 2, which is log 8. As simple as this. One more thing, which is not the same as, again, log a minus b, log of a minus b, and log a by log b. This is very important to remember. Yes, this is where usually students go wrong. All right, next. When the base and the number is the same, that is log a base a, log b base b, then the value of the log is equal to 1. For example, if you have log 5 base 5 or log 100 base 100, log 100 base, log 10 base 10, log 20 base 20, that is when b and a are the same, then the value of the logarithm is equal to 1. Okay, next. When b has a power, okay, so this power of b can be simply shifted to the left hand side and you can write it as n log b base a. Okay, let us take an example to quickly understand this. Now here you have log 81 base 3. which is the smaller number? 3. So can 81 be written in terms of 3? Of course, yes. How? 3 to the power 4. So this can be written as log 3 power 4 base 3. Now this 4 can be shifted to the left hand side where you get 4 log 3 base 3. Okay, and we know that when the value of b and a are the same, the value of logarithm is equal to 1, which means you get the value as 4 into 1, which is equal to 4. Okay, yes, next one. What you need to understand here is this is not the same as log b base a whole power n. Log b base a whole to the power n. Okay, this is not the same as log b base a whole to the power n. Which means if you have log 3 base 3 whole to the power 4, then the answer is not 4 log 3 base 3. It is log 3 base 3 is 1. 1 to the power 4. Answer is 1. I hope this is clear. Yes. Next, when the base has a power, that means log b base a to the power m. Now this power m can be shifted outside, but when you shift the power m outside, it becomes the reciprocal. That means m becomes 1 by m. So 1 by m log b base a. Okay, so here let's take an example. We have log 2 base 16. 16 is the larger number. 16 can be written in terms of 2. So 16 is 2 to the power 4. So this 4 can come outside as 1 by 4 log 2 base 2. So log 2 base 2 is 1. Answer is 1 by 4. Similarly here, we can write this as log 3 base 3 to the power 1 by 2, because square root of 3 is 3 to the power 1 by 2. Now this 1 by 2 can be taken outside. You get 1 by 2's reciprocal is 2. So you get 2 log 3 base 3. Log 3 base 3 is 1. So the answer is 2. Okay, next. Now when both the term b as well as the term m, that is the number and the base, have a power. So n goes as it is, and m becomes the reciprocal of itself. So it becomes n into 1 by m into log b base a. Okay, we have 2 examples here. We'll solve it. Log 81 can be written as 3 to the power 4, and square root of 3 can be written as 3 to the power 1 by 2. Now this 4 goes outside as 4 and 1 by 2 goes outside as 2. So what do you get? 4 into 2 by 1 into log 3 base 3. 4 into 2, 8. So you have 8 log 3 base 3. Answer is 8 into 1, which is equal to 8. Okay. Now similarly here, you have log root 2 base 16. Root 2 can be written as 2 to the power half, and 16 can be written as 2 to the power 4. So you have log 2 to the power half base 2 to the power 4. Half as it is, 4 as 1 by 4. Correct? Yes. So you get 1 by 2 into 1 by 4 log 2 base 2. So you have 1 by 8 log 2 base. This is your answer. Now, next property of log is log 1 to the base anything. Log 1 to the base anything is equal to 0. Log 1 to the base anything is equal to 0. Next one is change of base. Okay, next one is change of base. So if you have log b base a, and if you want to change the base from a to 10, that is the common logarithm. Okay, that is the common logarithm. What you simply have to do is write it as log b by log a. As simple as that. For example, if here, let's say you have log 2 base 3. You simply write this as log 2 divided by log. That's all. Okay, base is changed. Now you can go ahead with solving this. Okay, next is inverse logarithm. Inverse means, like I said, ulta, reciprocal. Correct? So when you take the reciprocal of a logarithm, log b base a, then a and b interchange their places. A and b interchange their places. So log b base a becomes 1 by log a base. Similarly, log 2 base 3, if you have find the inverse, this becomes 1 by log 3 base 2. Okay, and 1 by log 4 base 5 becomes log 5 base 4. Okay. So what happens when you take the inverse, that is the reciprocal, the values of A and B interchange their places. I hope this is clear till here. Okay. So that is it with respect to the properties of logarithm. Now, I want you to take out your I know the calculators are with you, but I want you to understand how to find the value of log of any number when the base is 10. Okay. When you consider this in the calculator, you will only consider the first 4 decimals of the values. Okay. So let's understand this quickly. Yes. Now, let us try to find, okay, let us try to find the value of log 2 base 10. Okay. What are we trying to find? The value of log 2 base 10. Okay. Log 2 base 10. So what is your first step? Your first step is to take the base in the, take the number in the calculator. Now, what is the number 2? So take 2 in the calculator, everyone. Done? Now, next step is to apply square root 15 times, 15 times. Okay. What do you do? The first step is to take 2 in the calculator. The second step is to apply square root 15 times. Square root is there in the calculator. Press it 15 times. Keep a count. Yes. Is this the value that you get? Okay. Next, you have to subtract 1 from the number and press is equal to. Subtract 1 and press is equal to. I hope this is the value that you get. Okay. Lastly, you have to divide this by a given number. This number you have to remember, the steps you have to remember. Okay. Lastly, you have to divide this by 0.0000, 0.0000, 70271, 70271, and press is equal to. What do you get? 0.3010. Like I told you, you can ignore the remaining decimals. Okay. You have to consider only the first 4 decimals. So what is the value of log 2? 0.3010. This is how you can find the value of log of any number using the calculator. Now, you know that the value of log 10 base 10 is 1. Correct? You know that the value of log 10 base 10 is 1. Now, let us understand how to get this value in the calculator. Let us understand how to get this value in the calculator. Okay. Now, what do you do first? You take 10 in the calculator. Correct? Yes. Apply square root. How many times? You apply square root 15 times. 1. Correct? Then you do -1. Then you divide this by 0.0000702771. Correct? Press is equal to. You get the answer as 1.000. I told you after the 4 decimals you need to ignore. Yes. Since we are using the calculator method, you'll get a slight variation in the answer. That's okay. But you can ignore after the 4th decimal. Up to the 4th decimal, it's 0. So the answer is 1, which we have already written. And we have also understood this with the help of the calculator. I hope it is clear until now. I hope there are no confusions till now. Yes? All right. With this, logarithms are done. You can just go through this. This is what I have explained it to you. Log of any number using the calculator. What is important here is the base should be equal to 10. So take the number in the calculator, apply square root 15 times, subtract 1, press equal to, and divide the number by 0.000702771. So these are the important steps. Okay. Yes. All right. I hope you're able to understand. Yes. Let's go to the questions. The calculator method is for you to check. Okay. Is for you to check. Be careful there. All right. Next questions. Log x is equal to m plus n. Log y is equal to m minus n. Find the value of log x by y square. Okay, fine. In terms of m and n. Now this, can I write this as log 10 plus log x minus log y square? Because this is in the form of log a into b divided by c, which is log a plus log b minus log c. Okay. Now, we know that log 10, when the base is not given, we consider the base as 10 here. So log 10 base 10 is 1. Now, log x is given as m plus n. Log y is given as m minus n. But my question is, can I substitute it here? You cannot, because what you have is log y. Here, what you have is log y square. And like I mentioned it to you, there is a difference between log y alone, log y whole square, and log y square. Correct? Now here, the power 2. In the question, the power 2 is applicable only to y. So our first step is to shift this to the left-hand side. So you get minus 2 into log y. Now you can substitute the value of log y as m minus n. So you get 1 plus m plus n minus 2 into m minus n. Open the brackets. 1 plus m plus n minus 2m plus 2n. So you get m minus 2m is minus n, and n plus 2n is 3n. 1 minus m plus 3. This is your answer. Yes, let's go to the next question. Question number 10. Here, there are more than 2 log terms which are multiplied with each other. Log 4 base 3, log 5 base 4, log 6 base 5, log 7 base 6, log 8 base 7, and so on. Correct? So now what we can do here is we can simply change the base. Okay. How do you change the base? You simply have to write this as log 4 by log 3 into log 5 by log 4, correct? Into log 6 by log 5 into log 7 by log 6 into log 8 by log 7 into log 9 by log 8. Now, log 4 gets cancelled. Numerator, denominator. Log 5 gets cancelled. Log 6, log 6, log 7, log 7, log 8, log 8. Correct? What remains is log 9 by log 3, which can also be written as log 9 base 3. 9 can be written as 3 square. So this becomes log 3 square base 3. Now this 2 can be written here to the left hand side. So you get 2 log 3 base 3. Log 3 base 3 is equal to 1. The answer is 2 into 1, which is equal to, this is a change of base question. I hope this is clear. Go to the next one. You have to find the value of log x to the power 6. And they've given log x plus 2 log x square plus 3 log x cube is equal to 14. Okay. Now, we can write this as log x plus x square can be shifted to the left hand side of the log. So it becomes 2 into 2, 4 log x. Correct? X square is there. 2 comes to the left hand side. 2 into 2 is 4. Plus 3 log x cube. Cube is there. 3 comes to the left hand side of the log. 3 into 3 becomes 9. So you get 9 log x is equal to 14. Now, since the log values are the same, log x, log x, log x, you can simply add the three terms. So 1 log x, 4 log x plus 9 log x, okay? Which is 1 plus 4, 5, 5 plus 9 is 14 log x is equal to 14. So you can shift this to the other side. You get log x is equal to 14 by 14, which means log x is equal to 1. Okay. Now in the question, what they have asked us to find is the value of log x square. Log x to the power 6, sorry. Log x to the power 6. The shift 6 can be shifted here. Get 6 log x. You know that the value of log x is 1. So the answer is 6 into 1, which is equal to 6. This is also an important type of a question. Similar kind of question has been asked in the exam quite a few times. Next question. Log xy square minus log y. Can I say this is in the form of log a minus log b, which becomes log a by b? That is log xy square divided by y is equal to log of x plus y. Now don't say this is log a plus log b. This is log of a plus b, okay? This is not log a plus log b. Okay, here 1 y can be cancelled. So what remains? Log xy is equal to log of x plus y. Now, both the sides log is common. When the log is common for all the terms on both the sides, the log can be cancelled. Now, they have asked us to find the value of y in terms of x. Okay. So, what we have to do in such a case is, wherever y is there, all those y terms should be got to one side. So, we'll shift this y here. We'll get xy minus y is equal to x. Take y common, you will get y is equal to, y into x minus 1 is equal to x. So you get y is equal to x divided by x minus 0. All right. Okay. With this, we are done with logarithms. We can go to the next chapter, equations. Okay. Now, we have 4 types of equations, correct? Yes. So what is an equation, first of all? An equation is a mathematical statement of equality, right? Now we have 4 types of equations: simple equations, simultaneous equations, quadratic equations, and cubic equations. One question or sometimes even 2 questions of quadratic equation is always there in the exam. So quadratic equation is something that is always asked in the examination. All right. Now, so what is a simple equation? A simple equation is an equation of the form ax plus b is equal to 0. Now here x is the variable and a and b are the constants, correct? A is also called as the coefficient of x, and the coefficient of x, that is a, cannot be equal to 0, because if a is equal to 0, then it is not a equation, because 0 into x is 0, then it does not amount to an equation. Okay. Now in case of a simple equation, the value of x has only one value or root or solution. Okay. Now here, if I ask you to find the value of x, you will get the value of x as 2x is equal to 6. So x is equal to 3, right? Yes. Okay. Now here, if I ask you what is a and b, what is a, coefficient of x, what is b, constant. Now to extract the values of a and b, you cannot just take it as it is. Why? Because to take the values of a and b, the equation should be in its form. What is its form? Ax plus b is equal to 0. Okay. Now is 3x is equal to 9 in its general form? No. So how do you take it in general form? 3x minus 9 is equal to 0. Now you can take the values of a and b. A is equal to 3 and b is equal to minus 9. I hope this is clear. This is your simple equation. Now moving on to simultaneous equation. So what is simultaneous equations? Simultaneous equations are either 2 variable or 3 variables. Okay. So now what is 2 variables? X and y. What is 3 variable? X, y and z. These are the forms of a simultaneous equation. Now, our main idea or our how we are going to solve simultaneous equation is by substituting the options into the question. Okay, we're not going to learn all this cross multiplication or substitution, all these methods we're not going to learn. We're just going to use the options in the given question. All right. Yes. Moving on to the most important part, that is the quadratic equation. First of all, what is the form of a quadratic equation? The form of a quadratic equation is ax squared plus bx plus c is equal to 0. Okay. X here is the variable, a, b, c are the constants, and definitely a cannot be equal to 0. How is it different from simple equation? If you observe carefully here, the variable x has power 2. Okay. The highest power of the variable x is 2. X square is there, x is also there. But the highest power of the variable x is 2. That is why it is called a quadratic equation. What does this mean? This means that x here will have two values or roots or solutions. Okay. X will have two values or roots or solutions. Now, very important to understand the formula to find the value of x. The formula is given as minus b plus or minus square root of b square minus 4ac divided by 2a. Now, this formula can be split into two parts. Okay. The first part being the first root and the second root. The first root can also be called as alpha. Second root is called as beta. Okay. The first root is alpha. The second root is beta. So here, when you say alpha, it is minus b plus square root of b square minus 4ac divided by 2a. And my beta is minus b minus square root of b square minus 2ac divided by 2a. Now, let us understand the formula using a question. X square plus 5x is equal to 6. Now tell me, can I take the value of a, b and c directly here? No, we cannot. Reason, because it's not in its general form. So what is its general form? X square plus 5x minus 6 is equal to 0. Okay. What is a here? 1. What is b? 5. And what is c? Minus 6. Now let's solve this using the formula. What is the formula? X is equal to minus b plus or minus square root of b square minus 4ac divided by a. So x is equal to minus 5 plus or minus square root of b square, 5 square is 25, minus 4 into 1 into minus 6, correct? Divided by 2 into 1. So you get x is equal to minus 5 plus or minus square root of 25 plus 24, that is root 1. And root 1 is equal to 1 divided by 2. So can I say we'll split the two roots? Alpha is minus 5 plus 1 by 2. And beta is minus 5 minus 1 by 2. You get minus 4 by 2, that is minus 2. And minus 6 by 2, that is minus 3. So these are the two roots of the equation. Okay. The other way to solve this is a very simple way. You just have to substitute minus 2 and minus 3 in the place of x separately. Okay, first you substitute minus 2, then you substitute minus 3. See, substitution of the option. So what is the equation given? What is the first value of x? Minus 2. What is the other value of x? Minus 3. Okay, simply substitute. You will get minus 2 the whole square plus 5 into minus 2 minus 6. 4 minus 10 minus 6, that is equal to 0. Sorry, 4. One minute. What is the value of x? Correct, no? Yes. Yes. You just have to substitute the value of x. Okay. So you get minus 2 the whole square, that is 4. Yes. Then you have plus into minus 2, minus 10, minus 6. That becomes 0. And then here, secondly, 1 minute. Yes. You just have to substitute the values of x in the options. You'll get the answer as 0. All right. Is this clear till here? Any doubts? All right. Next one is multiplying the factors. Okay. So what is this multiplying the factors here? What is this multiplying the factors? Now see here, what are the factors here? You got the value of x as -2 and the value of x as -3, right? Right? Yes, you got the value of x as -2 and the value of x as -3. Am I right? Okay. So now when you multiply the factors here, you get x plus 2 into x plus 3 is equal to 0. Okay. X plus 2 into x plus 3 is equal to 0. And when you open the brackets here, what do you get? X into x, x square, x into 3, 3x, 2 into x, 2x, and here 2 into 3, 6 is equal to 0. So you get x square plus 5x plus 6 is equal to 0. No, this is incorrect. Where have we gone wrong? Please check. Check where have we gone wrong. What is the first one, the formula? The formula method, where have we gone wrong? Check. Yes, where have we gone wrong? We've gone wrong somewhere here. Check, check, check. Check. I want you to be attentive. Check. Yes, very good, Disha. Good. Yes, very good. I was waiting for this. Yes, good. So here we have gone wrong. See here. You'll need to be attentive. See here. What is this? -4 into 1 into -6 is plus 24, correct? Yes. If you get square root of 49, that is 7, not 1. Yes, good. You all have to be attentive. Yes, okay. So you get 7 here. So here it is -5 plus 7. -5 plus 7 is 2, correct? Everyone, what are the roots? 2 by 2 is 1. And here -5 minus 7. Correct? What is the root here? -5 minus 7. What is the root? 12. -12. -12 by 2 is -6. Yes. Okay. So now these are the two roots. Okay. So not -2 and -3. Yes. All right. Now here, let's go ahead. So when you substitute it, you will get 1 square plus 5 into 1 minus 6, which is 1 plus 5 minus 6, that is equal to 0, the first root. And the second root is -6 the whole square plus 5 into -6 minus 6, that is 36 plus minus 30 minus 6, that is equal to 0. Okay, is this clear? Now let us multiply the factors. What are the factors? X is equal to 1 and x is equal to -6. So x is equal to 1 and x is equal to -6. This can also be written as x minus 1 is equal to 0 and x plus 6 is equal to 0. Now what you need to do? You need to multiply the factors. You get x minus 1 into x plus 6 is equal to 0. Open the brackets. You will get x square minus x plus 6x minus 6 is equal to 0. So x square plus 5x minus 6 is equal to 0. So what have we understood here? We have understood that however we get it, ultimately we'll arrive at the quadratic equation. Okay, moving on. How to construct a quadratic equation using the sum and the products of root. Now, the form of a quadratic equation is given as x square minus sum of roots into x plus the product of roots is equal to 0. So now what is sum of roots for us? Sum of roots is nothing but the sum of the two roots, alpha and beta, that is alpha plus beta. And what is product of roots? Product of the roots, alpha into beta. Now sum of roots can also be written as minus b by a, and product of roots can be written as c divided by a. Okay, let's use the same example to understand this. What were our two roots? Our two roots were 1 and minus 6, correct? What was our equation? Our equation was x square plus 5x minus 6 is equal to 0. And our roots were 1 and minus 6. Okay, now the sum of the roots. Okay, this is alpha and this is beta for us, which is 1 plus of minus 6, that is 5, correct? And sum of roots can also be found out using minus b by a. Okay, minus 5 here. Sum of roots can also be found out using minus b by a. What is b here? 5. Minus 5 by what is a? 1, which is equal to minus 5. Is this clear? Yes. So alpha plus beta or minus b by a, the answer is going to remain the same. Now product of roots. Product of roots is nothing but 1 into minus 6, that is equal to minus 6, or c by a. What is c for us? Minus 6 by a. A is 1. Answer is minus 6. Okay. Now by using the sum of roots and product of roots, you can get the equation. How is that? X square minus, what is the sum of roots? Minus 5. So minus 5 into x plus product of roots. What is the product of roots? Minus 6. So minus 6. Sorry, x square minus of sum of roots. So what is sum of roots for us? Minus 5. So minus into minus is plus. So x square plus 5x minus 6 is equal to 0. Is this clear? Next. Nature of roots. Okay. The nature of the root. The nature of root is dependent on the value of b square minus 4ac. Now what is this b square minus 4ac? B square minus 4ac is called the discriminant. What is b square minus 4ac? B square minus 4ac is here called the discriminant, which differentiate or distinguishes between the types of root. Okay, so if the value of b square minus 4ac is so and so, we can determine the nature of the root. So what are we determining here? The nature of the value of x. What is it based on? It is based on the value of b square minus 4ac. All right. So now if the value of b square minus 4ac is 0, then the roots are real and equal. Okay. If the value of b square minus 4ac is less than 0, then the roots are imaginary, and something that is imaginary we will not consider. It's not there in our syllabus for us. Okay. And when the value of b square minus 4ac is greater than 0, then you have two particular options. First option is it is a perfect square. When b square minus 4ac is a perfect square, then the root is a rational root. The roots are real, unequal, and rational. Okay. And when the value of b square minus 4ac is greater than 0 and not a perfect square, then the roots are real, unequal, and irrational. So if I ask you, if I tell you the roots are real, then can I say that the value of b square minus 4ac will be greater than or equal to 0? Because in both equal to 0 also as well as greater than 0, the roots are real. So can I say when the roots are real, the value of b square minus 4ac is greater than or equal to 0? Correct? And if I say the roots are equal, then the value of b square minus 4ac is equal to 0. Correct? If I say the roots are unequal, the value of b square minus 4ac is greater than 0. Okay. Now, important notes here, important to solve the questions. When one root of the quadratic equation is the reciprocal of the other. One root is the reciprocal of the other. Okay. So let's take an example here. All right. Let us say alpha is 5. If alpha is 5, can I say beta should be 1 by 5? Beta should be 1 by 5. Okay. Now, if you multiply this, alpha into beta, you will get 5 into 1 by 5, correct? Which is equal to 1. So can I say product of roots is equal to 1? Now, if the product of roots is equal to 1, if the product of roots is equal to 1, can I say that C by A is equal to 1? Therefore, C is equal to, which means the product of roots is equal to 1 and C is equal to A. That means the constant C is equal to coefficient of x square A. Is this clear? Everyone? Yes. Next. If one root of the quadratic equation is equal to the other in magnitude but opposite in sign. Now, what is this equal in magnitude but opposite in sign? Equal in magnitude means the value, the quantity is the same. That means if one root is 5, the other root is also 5. But opposite in sign means if one root is 5, then the other root is minus 5. If one root is 5, then the other root is minus 5. Okay. So if I consider alpha as 5, beta will be minus 5. Equal in magnitude, but opposite in sign. So if you add these two, alpha plus beta, you'll get 5 plus minus 5, which is equal to 0. 5 plus minus 5, which is equal to 0. Correct? So alpha plus beta will be equal to 0. That means minus b by a is equal to 0. Correct? Sum of roots. So can I say minus b is equal to 0, therefore b is equal to 0. So the term bx won't be there because b is equal to 0. 0 into x is 0. So can I say that sum of roots is equal to 0 and b is equal to 0? Is this clear? Yes? Okay. Next. Third note. Irrational roots. What is irrational roots? For example, 2 plus root 3 or 2 plus root 5 by 2, something like this. These are irrational roots where the value of b square minus 4ac is not a perfect square. Okay. Irrational roots occur in pairs. They're called conjugate pairs. What is this conjugate pairs? It means if alpha is 2 plus root 3, then beta will be 2 minus root 3. Similarly, if alpha is 2 plus root 5 by 2, then beta will be 2 minus root 5 by. This is what you understand by irrational roots occur in conjugate pairs. Okay. Lastly, cubic equation. What is cubic equation? An equation in the form of ax cube plus bx square plus cx plus d is equal to 0. Correct? Where x is the variable, a, b, c, d are constants, a is the coefficient, and a cannot be equal to 0. And here, because the highest value of x, highest power of the x is 3, x will have 3 values or roots or solutions. Okay. With this explanation is done, we can start with the questions. Okay. The first question. What is given there? It's given the sides of an equilateral triangle are shortened by 3 units, 4 units, and 5 units respectively, and a right angle triangle is formed. Okay. The sides of an equilateral triangle are shortened, and what is formed? A right angle triangle is formed. All right. So what is, first of all, what is this right angle triangle? What is a right angle triangle? A right angle triangle is a triangle which has a 90-degree angle. Correct? And the side opposite to it is called the hypotenuse, and this is the longest side. You've heard of something called as Pythagoras theorem? So what does Pythagoras theorem say? Pythagoras theorem says that the longest side, let's say A here. So the square of the longest side is equal to the sum of squares of the other two sides. This is what the Pythagoras theorem says. Right. Now, what have they asked us to find? They have asked us to find the equilateral triangle side, which is same, correct? Equilateral triangle means what? Where all the sides are the same. Okay. Now, let's say the side of an equilateral triangle is 5 centimeters. Example, okay? Option A. Equilateral triangle side is 5 centimeters. It has been shortened. So shortened means reduced. 5 minus 3, 5 minus 4, and 5 minus 5. 5 minus 3, 5 minus 4, 5 minus 5. Is this possible? 5 minus 5, 0 centimeter. Can it be 0? No. Quantity can never be in 0 and negative. It is always positive values. Can you have a side being 0 centimeters? No. So can I say option A is incorrect? Okay. Good, option B. 6. So you have 6 minus 3, 6 minus 4, 6 minus 5. Correct? 6 minus 3 is 3, 2, and 1. Which is the longest side here? 3 centimeter, correct? 3 units. So 3 square is 9. And sum of the squares of the other two. So 2 square plus 1 square, that is 4 plus 1, that is 5. Can I say they are not equal to each other? So option B is incorrect. Okay. Moving on to the next option, that is option C, 8. What is 8 minus 3? 5. 8 minus 4 is 4, and 8 minus 5 is 3. Longest is 5. 5 square is 25. Now 4 square plus 3 square. 4 square is 16. 3 square is 9. 16 plus 9 is 25. So can I say option C is your answer? Yes. So this is your question. Next. A number consists of 2 digits such that the digit in the ones place is thrice the digit in the tens place. Okay. Now let us say we have a 2-digit number 12, example. Or let's say 3-digit number 312. Now this is your ones place or units place. Okay. This is your tens place, and this is the hundreds place, and so on. Okay. Now what have they said here? The digit in the ones place is thrice the digit in the tens place. Okay. Which means whatever is in the ones place should be higher than tens place. Option A, 62. 6 is higher than 2, correct? So tens place is higher than ones place. So can I say option A is incorrect? Go to the next option, B, 26. 6 is higher than 2. Now is 2 into 3 equal to 6? Of course, yes. So can I say the digit in the ones place is thrice the digit in the tens place? Tens place is 2. 2 into 3 is 6. Done. Next, it says, if 36 be added, then the digits are reversed. Okay. So 26 is the number. Add 36 to it. Correct? 26 is the number. You need to add 36 to it. So 26 plus 36, what is it? 26 plus 36 is 62. Has it reversed? Yes, it has reversed. 26 has become 62. So can I say option B is the answer? Yes. Okay. Question number 3. Question number 3 is actually a simultaneous equation question. You have to find the roots of x and y. But like I told you, you will not be using any method. What I would want you to do is simply substitute the options. Okay. Now option A, they have said x is equal to 2 and y is equal to 1. So you get 4 to the power 2 into 8 to the power 1. That is 16 into 8, right? 16 into 8. So what is 16 into 8? 128. Satisfied? Next you have 3 to the power x. That is 3 to the power 2 divided by 27 to the power y. That is 27 to the power 1. 3 square is 9. 9 by 27. 9 by 27. 9 ones are 9. 9 threes are 27. So the answer is 1 by 3. Option A is your answer. Yes, just a minute. Question number 4. The value of P for which the difference between the roots of the equation is 2. The value of P for which the difference between the roots of the equation is 2. Okay. Now, here, what is the equation given? X square plus px plus 8 is equal to 0. Difference is 2. That was alpha minus beta is equal to 2. Okay. Let's say A is 1 here, B is equal to P, and C is equal to 8. Correct? They have said alpha minus beta is equal to 2. Okay. Now here we know that alpha plus beta, that is sum of roots, is minus b by a. That is minus p. And alpha into beta, that is product of roots, that is c by a, is 8 by 1, that is equal to 8. Correct? Yes. Now, what we need to do here is, to make it simple for us, we'll square this. You'll get alpha minus beta the whole square is equal to 4. Okay. Now, alpha minus beta the whole square is nothing but alpha square plus beta square minus 2 alpha beta, which is nothing but the identity a minus b the whole square. A square plus b square minus 2ab. So alpha square plus beta square minus 2 alpha beta is equal to 4. We don't have alpha square plus beta square. We have alpha into beta and alpha plus beta. This comes in the identity alpha plus beta the whole square. Sorry, this comes in the identity a plus b the whole square. That is a square plus b square plus 2ab. So if I shift this here, I get a plus b the whole square minus 2ab is equal to a square plus b square. So substitute alpha and beta in the place of a and b. You'll get alpha plus beta the whole square minus 2 alpha beta is equal to alpha square plus beta square. So you get alpha plus beta the whole square minus 2 alpha beta minus 2 alpha beta is equal to 4. See, for this term, you have substituted these two terms. So you get alpha plus beta the whole square minus 4 alpha beta is equal to 4. Now substitute. You will get minus p the whole square. 4 into 8 is equal to 4. 4 into 8 is 32. 32, when you shift it to the other side, it becomes plus 32. So p square is equal to 36, which means p is equal to plus or minus 6. That's it. This is your answer. There's only plus 6, so you'll only go with plus 6. Okay? Yes. All right. Okay. Now here, solving the equation, the value of m works out to be. You just have to substitute the value of n in the options, from the options to the question. That is all that you need to do over here. Okay? I'll directly pick the correct option, which is option B. You get 1 by 25 plus 1 by 5. Why 1 by 5? Because square root of m. That is 1 by 25 square root is 1 by 5. Take a common denominator, you get 25. Here 1 and here 5. Because 5 5s are 25. You're taking the common denominator is 5. So 6 by 25 is the answer. That's it. Okay. I hope this is clear. Let's go to the next question. All right. I'll explain this question. Okay. The entire solution will be your homework. I'll just explain it to you. How to start. Can I consider the value of A as 1, B as 7, and C as 12? Okay. Now here, what have they asked us to find is alpha square by beta plus beta square by alpha. By taking the common denominator, we can also write this as alpha cube plus beta cube divided by alpha beta. Okay. Alpha cube plus beta cube is there in the identity a plus b the whole cube, correct? Which is a cube plus b cube plus 3ab into a plus b. Just shift this 3ab into a plus b to the other side. You will get, I'll substitute this as alpha and beta, alpha plus beta whole cube minus 3 alpha beta into alpha plus beta is equal to alpha cube plus beta cube. Okay. Now, in the place of alpha cube plus beta cube, you will substitute this value here. Entire value in the place of alpha cube plus. Okay. Alpha plus beta is minus b by a. That is minus 7. Correct. And alpha into beta is c by a. That is 12. Okay. So the remaining part, substitution part, becomes your homework, which is similar to what we have done in the question number 4. Quite similar, substituting. Okay, next, 7th. I know there's 2 minutes, but we'll quickly complete it, okay? 7th question. The value of k is, if 2 is the root of the cubic equation. Okay, if 2 is the root of the cubic equation, that means you can substitute x as 2. So in the place of x, we'll substitute as 2. So you get 2 cube plus minus k plus 1 into 2 plus k is equal to 0. When you open the brackets, you'll get 8 minus 2k minus 2 plus k is equal to 0. Simplify this, you'll get 6 minus k is equal to 0. Shift k to the other side, you'll get k is equal to 6. That's all. That's it. Okay. Last question. The roots of the equation x cube plus 9x square minus x minus 9 is equal to 0. Okay. So what you need to do here is you need to individually substitute the value of x from the options. Okay. So first, let's say x is equal to 1. I'll show you for one option. The remaining 2, you need to do it on your own. So if you substitute x as 1, you will get 1 cube plus 9 into 1 square minus 1 minus 9. So 1 cube is 1 plus 9 minus 1 minus 9. So 1 plus 1 here. Plus 1 minus 1, 0. Plus 9 minus 9, 0. So similarly, when you use option A to substitute the value of x as minus 1, then you will also substitute the value of x as minus 9. Now remember, only if the first value satisfies, go to the next value. Else skip the option and go to the next option. I hope this is clear. Okay. One more important thing here. If 1 does not satisfy, then any option with 1 will be cancelled. Example, I'm just giving you an example. Here 1 satisfies. But I'm just telling you that if the value 1 does not satisfy, then any answer with 1 will be eliminated. Is this clear till here? All right. So I think it's time. Yes. We will stop here for today. I hope you learned something. You're carrying something out from the session. We will meet tomorrow at 10 a.m. and we'll start with we'll finish linear inequalities and then quickly start with time value of money in tomorrow's session. Have a great day. Continue studying and continue working hard, because if you work hard, you will be able to achieve what you want. Just by sitting at home, not doing anything, you cannot curse or tell yourself or anything for that matter. So please work hard. I'll see you tomorrow. Have a great day.